All right. Good morning. My name is Savannah Miller. I know there's literally only just a couple people here that are not K State people, which is perfectly fine. I have not had a good chance to actually introduce myself and say what I do. Usually it is Edwin Chavis who is up here. He has had some other engagements today, and then Joni Nelson also she's at the state fair, which is where I'm assuming most people are today. So I am the Southern Agriculture Research and Education Model State Program Assistant. I know that's a very long title. Literally, so basically what I do is I am a program assistant. It's what we call SARE. This is the program that funds Third Thursday. Um, so I just want to welcome everyone and thank you for being here. I know that the biggest draw is that lunch is free. So, but thank you again for being here. We really, really appreciate it. And I hope that you all enjoy who we have gotten to speak today. I know the speakers are very excited about being able to present here today. Just a couple announcements. So we are going to actually add a September 4th Wednesday. So that's our beef cattle meeting. We usually only do 3 in a year, but we are adding a 4th one. So that will be September 24th. So that's next month. Again, dinner will be provided. It starts at 6 p.m. with dinner, and then we usually do a couple speakers and maybe a demonstration. So if that's something that you all want to come out to, please feel free to join us. And then we also, our big thing for this year is our Small Farmers Conference that is taking place November 18th through the 20th. A lot of the conference will take place here at the KSU Farm, but we will also be having a health fair on the last day at the Capitol Plaza Hotel. And we will also be having our banquet at the Capitol Plaza Hotel. If you would like more information on the Small Farms Conference, please feel free to reach out to me. And if you grabbed an agenda, my email is on the back. All right, so our first speaker today is going to be Lauren, Richard, and Kavita, if you all want to come up. And thank you.
Maybe I'll take one more.
Yeah, you look better, so.
Oh,
ALA is not sponsoring the talk. However, there is a new ALA Tech State collaboration, and if you want to try it, there's a vending machine in the front room. Highly recommend.
that's definitely a late promotion.
Good.
Okay.
I think, can we do it? Oh, we're learning. Bear with us. Okay.
Hi everybody, my name is Kavita Podel. I work as a research associate with the Geospatial and Environmental Science Research Team here at Kentucky State University, and I will let Richard.
Hello everybody, my name is Richard Schmickler, and I am the Extension and Site Coordinator for Kentucky State University.
In Martin County.
In Martin County.
I'm Lauren Traits, and I am the Field Research Coordinator also in Martin County. And Richard and I work both on the research sites that we have in Martin County. We'll be telling you all a lot about it, so we'll save that. And with the community out there on the West Virginia border.
Thank you. So today we are going to talk about some of the background of the site that we are researching on, our research approach there, which we are mostly doing using GIS and remote sensing, some of our findings that we got from our technology adoption survey in Kentucky. We will talk about GIS in farm planning, ArcGIS survey 123 for farm monitoring and records, water source mapping and tracking using GIS, carbon and ecosystem monitoring, drone applications, student engagement and partnership, and how farmers and KSU can be a partner together in mapping out their farms.
Awesome. Now I have my own mic. So I'm just going to be giving you all a little bit of an overview, giving you a sense of the place from which we are speaking and some of the contexts that surround our research and that have implications for the farmers and landowners that we work with in Eastern Kentucky. So I'm sure most of you, since you're sitting in a room in Kentucky, know a heap about coal, maybe a little bit less about the reclamation process, but this is part and parcel to our work. Richard and I have been living on a reclaimed mine site and overseeing different research projects that have been occurring through the Kentucky State University, as well as providing demonstrations, tours, workshops for the public. And most of the people who are coming up to learn with us don't also live on a coal mine, but they are greatly impacted by the history of coal, which is one that is incredibly proud and has defined a lot of their lives and multi-generationally, but has also left a lot of challenges for folks both physically and environmentally. These sites, particularly the mountaintop removal sites, leave behind a lot of environmental liabilities that are addressed through reclamation, but don't get us to a place where we don't have trickle-down effects on the surrounding communities. So the mine land reclamation process is one in which they attempt to put a mountain back into its approximate original contour. So they basically kind of reshape it, usually using terraces. And then they will seed this, and historically have done so predominantly with a few key invasive species that can grow rapidly and successfully in that poor soil, but that dominate our native species and ultimately tend to creep their way into our neighbors' areas. I'm sure everyone in here is familiar with autumn olive, which is one of the favorite culprits. So, you know, when Richard and I are working in the field, a lot of the things that we're experimenting with and demonstrating need to have relevance to the folks around us and the impacts that they're experiencing as a result of that history of coal and reclamation. And so being able to share how some of these ecosystem level monitoring, mapping projects that have been occurring can help inform them and their lives has been critical to what we do. And so that's speaking to those downstream impacts as well. Just to name a few, some of those are, you know, obviously deforestation is part of mountaintop removal. And so without that tree canopy or the topsoil that remains, or that used to be there, you end up with things like water retention issues, higher flood risk, changes in like heat regulation in the environment, erosion issues, and various things like this. So those do ultimately affect everybody surrounding those areas as well. And this could be true even here in Frankfurt, where there isn't that history of mining. If you're near an industrial park or a development or something that's altered the ecosystem, hopefully our research ends up being impactful in that way too. And yeah, I think that's enough about intro for now. More stories will come.
Okay, so Lauren gave some context about the mine site. This is where most of our research activities are going on. We are mainly focusing our research on studying how all of this mining and the reclamation that follows mining is shaping the landscapes of that region and how it is affecting the ecosystems. When we talk about ecosystems, we are looking at how mining and reclamation has changed the soil, water, vegetation, and microclimate of that region, and that is our main research focus. Besides that, we are also partnering with communities, and we also did a survey on how they want these mine sites to be used, and what is their experience with current reclamation. Are they happy with it? And what would they like to see on those mine sites? And we are also in that way partnering with communities to get their view on this problem. And also the whole purpose of this research project is to identify some suitable land use that is going to be not just environmentally friendly, but also economically sustainable, so that these communities can utilize these lands. So we are partnering with Renew Appalachia, which is a nonprofit organization working in the Martin County, and they are also doing the same, and we are just helping them with the avenue of research. So in these areas, needless to say, are very difficult to reach to some parts. They don't have roads everywhere, and since these areas, these reclaimed sites, people put the companies, they put the soil back, and somewhere it's not even. There are like pits and not even surfaces, so it's hard to reach in some of these areas. And remote sensing and GIS has really come in handy. Before I keep saying GIS and remote sensing, let me say a little bit about what GIS and remote sensing is. So GIS stands for Geographic Information System, which basically means pairing location with the information. For example, we can say in your farm, you have like maybe 100 acres of land, right? And then in your farm, you have some orchards, some livestock, and then if you pair all of that information in your farm with the location, like where those where those things are, where your orchard is, where your barn is, all that stuff. When you pair location with all that information, then it becomes geographic information system. So it's not actually really new concept. We have been doing that, but so GIS as a tool allows you to analyze all that information about your farm and about other areas too in terms of location, and helps us visualize the information in a map. So that's what basically GIS is. And remote sensing, the term itself stands for sensing remotely, right? So which basically says that not going to that place itself to get the data, but using some other remote methods in order to get data and information about a certain place. For example, if you fly a drone, for example, I'm staying here out in the farm, I want to know how the soybean crops that the students planted are doing. And then I will fly a drone standing right here. I don't have to go there. And then I will get the image of that soybean plot. And I will not just get the image. I will also get other data that my normal human eyes cannot see. So remote sensing allows us to see in those areas which are remote and also which my normal human eyes cannot see. So that is what basically remote sensing is. So what we normally do in these reclaimed mine sites is we collect aerial imagery from drones, and we also collect LiDAR data. So again, it's a technical term, sorry about that. So LiDAR basically means that, so we have a sensor that is mounted on a flying device, either it's a drone or an airplane, and then sensor, when it goes through, it drops the pulse. And based on the time it takes to get the pulse back to the sensor, it can calculate the whole entire map, 3D map of the area. For example, if I were to fly LiDAR in this room, then I would be able to see in the image all these tables, chairs, and height of each of these tables and chairs. So that's really cool. And we also do that in the mine site. So what it allows us is, it allows us to look at how high the vegetations are, and what's the terrain look like. Is it flat? Is it slopey? So LiDAR data allows us to do that. So we are using drones in order to get the image of that place, and also for getting the 3D structure of that place, and also the terrain and the landscape. And so what other methods we're using is, so as I told you, we are looking at soil, water, and different components of ecosystem in that place, right? So we don't just go there and collect samples. So we do it systematically so that the samples that we collect are representative of the whole site. So we plan that using GIS. So GIS is a tool. It's a software. It's a computer software which allows us to do that. So how we do that is so how we use GIS for soil and water sample is we look at how that look like from computer. We don't have to go there. I can sit here and look at the image of that place, And I can also look at the LiDAR data, and based on all of that information, I can generate other models. So as for example, I can generate slope, I can generate like what side it is facing, which is called aspect, and I can look like how high the place is. I can look at how far it is from the roads, because field sampling can be sometimes dangerous and difficult, and we don't want to go too far out, right? So we also want to make sure that it's fairly close to the roads, but also at the same time represent the area, because we just don't want the areas besides the road as well. So all of that information we gather together in a software, and based on that we make decision on where and how many samples we need to collect. So that we do that, and that's the GIS-based planning. And also, after we got the data, for example, I have these. So for example, this is a flood, and I have like 6 points for these soil samples that I collected in 6 points. And then after I got the data, I can pair that information with the points, and now I have, for example, nitrogen value for each point. And then if I have that point data, I can map out for the whole field. So if you all decide to take soil sample of your entire field or a plot or a piece of land, and then send it to the UK soil lab or somewhere, and then get the results back, if you are using GIS, you can pair that information, location information, with the data that you got, and you can look at how your whole area looks like, and which area needs intervention, which area needs maybe, hey, so this area looks like it doesn't have that much nitrogen, maybe I need to put more nitrogen in there. So it helps you to make decisions that way. And that is called analyzing spatial patterns. Spatial basically means it's location patterns. Spatial comes from the word space. So spatial patterns means what is the pattern of certain thing, certain parameter in that space. And we use ArcGIS, Survey 123, to record soil, vegetation, and management data in the field. We'll talk more about this. Sorry, I covered a lot of my presentation already, because I'm talking all technical terms, and I want you to be aware of what those means before I go on and on. So ArcGIS Survey 123 is kind of like a mobile software. So you can add all the questions. So for example, you are traversing in your field, right? You're looking at how your field looks like, are the crops doing well, are the animals healthy, all that stuff. And then you can go in there and put information about all of that. Like you can pre-make your own survey, and then also put location information in there. For example, if this was your soybean field, you go in here, you pinpoint the location, and you say this is a soybean field, and now you put information about, are the plants doing great, and does any of the area look improvement? You can also take a picture. So ArcGIS Survey 123 allows you to do that, and then that way you can record soil, vegetation, and management data in the field. So our whole goal of these projects that we are doing in the Reclaim Mine site in Eastern Kentucky with the partnership with Renew Appalachia is monitor landscape change, and then we want to guide the post-mining land use of that area. And if you're not aware, many mountains, I think it's almost
1.2 million acres
yes.
of reclaimed mine land
yes.
throughout Appalachia.
So there is 1.2 million acres of these mine sites which are just laying there barren, or otherwise there is nothing growing on there, mostly, except a few people are doing stuff. And we want to find out what people can do in there so that they can benefit economically, and so that also it is also helping the environment. So that is the major goal of our project.
Kapita, if I could just say one quick thing, which is before any of this research has occurred, of course there are folks in Appalachia who are finding ways to use this land, right? So we have met multiple folks on the ground who have run cattle or attempted to do various forms of agriculture on these landscapes. They run into problems, and they also invent a lot of solutions. What we don't have is that measured, known, so that we can get what they're finding and then what we're finding out to other folks. Because a lot of the innovations that are occurring on a mine site have value to add I think, to all of us. So when it comes to that land use piece, there's a lot of folks who probably lean towards wanting to use them for recreation, but the second, like the equally desirable thing we're hearing from folks on the ground is that they want to be able to farm these lands and make them productive.
Yeah, also, it's really wonderful that we are doing so much good research to create systems that help people understand ways to solve issues on these mine sites and improve these mine sites. And I think that there's so much opportunity here with like different organizations that are doing similar stuff like this, like Coalfield Development running a lavender farm on a reclaimed coal mine site, or running sheep operations on reclaimed coal mine sites. So it's excellent to bring that research component in to all of the amazing farmers' knowledge that exists on how to utilize these lands and really do that, what KSU and land grants are meant to do, which is combine research with the actual people on the ground in the community doing their farming.
Do you want to do this slide?
Sure. So there have been a lot of different activities happening on this site in Martin County, including planting trees. This was with Green Forest Works, who has created the cross-ripping reclamation approach, which involves decompacting the soil and then putting native species back in. And this method has been used on a lot of mine sites and is a really good way to help try to bring back the native species. And it also, by overplanting with native species, you can crowd out the invasive Sericea lespedeza or the autumn olive by creating a canopy cover. We also, we have a pawpaw orchard that's on the site as well that is part of researching how to get pawpaw establishment. Much of the land, when they reclaim mine land, they have to state a use for that land, and that determines their reclamation approach. The most common one that you will find is wildlife habitat. There's a lot of interesting things being done as to how to better make sure that that wildlife habitat is actually beneficial for the wildlife that is there. And one of those things that has been helpful is the Southeastern Kentucky Sheep Producers Association is really working, and this is Patrick Angel, who's one of the founders of Green Forest Work, actually, is about using sheep as an invasive species management tool so that you can use them to eat the Sericea lespedeza, which helps to manage the invasive species, produces food, which is also a commodity that creates jobs and food security and income for the region. And then also, they do what all animals do, which is they create compost as you rotate them around the field, which helps to rebuild topsoils on these mine sites. And this is a great way that you can use GIS and drones to be able to track vegetation growth and canopy cover and look at all of the different impacts, soil erosion, water flow, wildlife habitat, and you're able to see the impacts of what you're doing. For instance, using drones to fly over a field before you introduce sheep to that area and be able to understand what the vegetation and coverage looks like and be able to then come in and get soil tests and everything to understand the soil composition. And then as you do different various practices with rotational grazing with livestock, then being able to use your drone again to be able to see how the vegetation has changed and what the proper amount of time to keep how many sheep on how many acres before they eat it down to how much to make sure you're having the maximum health of your pastures and the maximum production of topsoil.
Kabita was talking about how one of the benefits of remote sensing in GIS is that she can be right here and get information out there. Well, when she flies her drone over, me and Richard are out there scrambling over rocks and chasing after sheep and really doing that on-the-ground work. So part of the reason we're here to present is because we are getting to have an experience that we hope more and more farmers and land managers get to have as these technologies become more available, which is to be working in partnership with folks using planning technology so that when we're on the ground, we have a way more systematic approach, we know where we're supposed to be, and we can revisit those places consistently for all of our record keeping.
Most farmers know, I think anybody who does farming here would know, Farming is basically just moving stuff around at the right time. And that's a huge piece of what that is. And drones and GIS technology is an excellent tool to be able to figure out when you should move what things to where at the right times. And what you're seeing here, these are the sheep that were lent by the Southeastern Kentucky Sheep Producers Association that me and Lauren care for to do rotational grazing to manage Sericea lespedeza.
Yes, and the other, can you also?
Oh yeah, the other one is that was the planting day of a experimental pawpaw orchard to try to determine what it will require to be able to establish pawpaws on a reclaimed mine site.
If you notice on the image how you have flat, slope, that is a very familiar thing that you will see when you go to reclaimed surface mines. That is what we were talking about of the approximate original contour, where they try to reshape the mountain into what it looked like before as a series of terraces that allow them to drive D9 dozers and heavy equipment to compact the soil in order to try to prevent erosion and like rock slides falling into people's houses and such.
So I wanted to also talk about one of the surveys that we did from Kentucky State University, and we did this survey on technology adoption. It was all over Kentucky, and we got some interesting findings. So about 24% of the surveyed farmers, they adopted precision agriculture technologies. And so we're going to talk more about precision ag, our other presentations, in our other presentations too. But precision ag means using technology in order to manage your farm and in a way that you can optimize resources and get the maximum benefit. So I will let other guys talk in detail about that. But a lot of it is interesting to see that even 24% of the farmers have been using precision ag. That's a really good number for now. We are hoping that more farmers utilize precision ag in their farm management. So GPS was the most commonly utilized tool. I have been talking about GIS. GPS is a little different than GIS. GPS stands for Global Positioning System, which basically gives you location. GIS also combines information with the location, but GPS mostly gives you the location of the farm. For example, in some of the farmers may be using GPS collars in some of their animals in order to track their movement, in order to make sure that they are staying in the barn, not like wandering off or staying in the pasture, right? So that's an example of GPS. And farm size and the longer years of farming experience, it increased the likelihood of adoption of technology in agriculture. And we also found that older farmers were less likely to adopt. So I think that may be because, I'm old already. I'm not going to learn all of these technologies.
Well, they have their ways.
Yeah.
If it works, it works.
Yes. I mean, I'm just, that is my assumption. That is my assumption. But yeah, like if you have a will, there's a way, and we come right at that place, right? So, so the main reasons farmers don't use the tools are too expensive, it's too complicated, and not enough profit. That's what the farmers said. So our recommendation is that policies should focus younger farmers to try new tools in farming. The tools and these technologies should be made affordable and designed for small farms also, not just big farms. And small-scale farmers should be focused for targeted training and resources to use the tools. And there should be focus on cooperative farming, economic incentives like subsidies and hands-on training. So these is our recommendations for whoever makes the policies. And if you want to find out more, here's the paper, and you can scan that, and it will lead you to the whole paper. So this is another paper from the same survey, and we found out that so this is about the factors that influences the learning attitude of farmers regarding adoption of farming technologies in Kentucky. And we found that almost 86% of the farmers believe that precision ag will have important role in livestock and crop production in the future. And indeed it will. So the preferred method of learning for farmers, they would like to learn from workshops, seminars, trainings, social media, and printed materials. So as a KSU, being a land-grant institution, our focus should be in these methods as well. And the educational level of farmers and social media use, they have positive influence on the learning behaviors of farmers regarding technology adoption. If you want to access the full paper, you can scan the QR code. And our recommendations are policies should focus on the promotion of precision technologies in farming. And extension agents should focus on disseminating information via trainings, workshops, and seminars. So maybe we should focus a little more on the precision technologies, and the integration of social media should be integrated with other extension activities. So social media is a big thing nowadays, right? Everybody uses them. So maybe we should disseminate it that way as well. This is for KC people also. So yeah, back to GIS. So now we are going to talk some of the applications, how you can use GIS in your farms. So you can use GIS in order to identify some suitable crop and pasture zones. So you can find out which area of your land is suitable for certain crops. So for example, not all crops have same requirements, right? For example, corn may have separate requirement than the soybeans, or some orchard may have a separate requirement than the field crops, right? So if your farm is not labeled, maybe you wanna do something in the slopey areas, and in the flat areas you wanna do something else. So GIS helps you to plan and zone out those crop and pasture areas. And even though your farm is small or large, it will help plan and scale that planning based on your farm size. And also, that way you can improve efficiency, so you don't have to always go out in the field. You can plan, and planning improves the efficiency and also improve the sustainability of your farm. And in the picture over here, okay, yes. Here you can see that this is one of the research, but I wanted to bring in here in order to see how this works. So what this research did was, this research combined soil properties variables like soil depth, soil pH, texture, soil salinity, and climate variable, rainfall, and other topographic variables, elevation, slope. Elevation basically means the how high your farm is located from the sea level, and infrastructure variables like how far is it from the road or river. And then NDVI, which basically means it is a way of finding out the health of your vegetation, and land use, land cover. So what is the land use, or what's in the land, what's the land cover? And so all that information they combine together, and they give different weights. So for example, in some cases, being close to road may be more important than the river in some cases. So that really depends on your use scenario. But based on all of these topographic variables, they found out the suitability for the vineyards. So here you can see, so the dark green areas shows that the areas that are highly suitable, light green are moderately suitable, and the orange are marginally suitable, and the red areas are the areas which are not suitable. So you can do something similar. So I know it may be a little too complicated, but you can do this, and we can help you out with that as well. Yeah, and in the picture on here, so this basically shows how you can zone out different areas. So they have prepared kind of like a boundary over, in across the field to show different zones.
I just want to add that, so it is complicated when you have to hold like 10 factors in your mind. But I think probably most of y'all, if you've grown things or managed land or worked with animals, that analysis that we're trying to make really systematic here is you'd probably call it common sense. So it'd be what you've come to learn about your land and that kind of instinct you develop through practice of being able to say, I think it's likely that this is going to be able to grow well here because I've seen it grow well in these conditions in the past. So what this is really trying to do is to take that field knowledge, those factors that you've learned to think and learn to determine are important, and to allow you to collect large-scale information to be able to make better predictions. So in a way, it can feel really complicated when we lay it all out in these terms, but I think probably if you've walked your field before, you already have a good sense of some of these individual pieces from the ground. And so when we can work with a farmer who says, I want to grow this thing, and I know that what's important is that it needs a lot of water, it needs certain type of soil, it tends to do well on a south-facing slope, it tends to have a hard time when it's next to this other plant. Those all become points that then allow us to do something like what Kavita's describing here, so that you can maybe expand or contract what you're doing based on the whole ecosystem you're working with. So feels complicated on the level of analysis, but really those data points are each very real world things that you're already observing about your land.
So I briefly talked about how you can use ArcGIS Survey 123 for farm monitoring and records. So whoever joined us late, let me again briefly describe what ArcGIS Survey 123 is. So ArcGIS Survey 123 is a GIS tool. You can use it in a mobile device, and you can add information in there, anything relevant that you need, along with the location information, so that you can map out all that information and visualize it. So ArcGIS Survey 123 allows you to do that. It can be an excellent farm monitoring and recording tool. So what it allows you to do that is it helps you verify the location and health status of the crop, right? I already described this. You go along the field, you see, you have different crops, and then you see if certain parts of certain areas of certain crops need attention, and you can record that in ArcGIS Survey 123. And once you go back, and you can plan for what you can do in order to make those plants healthy again. Right? And then you can keep digital inventory of your crops, of your fertilizers, of your livestock. So for example, you have a barn, and then you have all of these. So for example, you have different houses, and then you put crops in one of the houses, right? And sorry, you put seeds in some of the houses, and you have fertilizer in a different section, and you can map out where those are. And that would be, especially if you're doing a large operation, that can be really helpful. And you can also use collars on GPS collars in your livestock devices, so you can track their movement. You can track if all of them are there, and that makes herding really easy as well. And you can also, all of this information lets you plan and track farm operations, and it's really easy to use on mobile device. So on the picture here, okay, here you can see that how it works, how Survey 123 works. So you first create your own survey asking questions. So you ask questions. So for example, your questions can be, what is the crop, right? Either it's soybean, or corn, or vegetables, or something. And your next question can be, are the crops healthy? Or how much is the acreage of certain crops? And are the crops doing well? And you can add a picture. You can add a section where you can add notes in there, and you can have the location component added to it. So those all would be your questions. You create and share those questions, and then you get answers. And you alone don't have to get answers, so that so for example, I can create a survey, and all of you can go out in the field and collect data. So that makes your job easier, right? And then you get answers, which is basically capturing the data. And then based on the answer that you get, you make decisions. You view the data, analyze the data, and then make decisions. So this is an example of, sorry, I'm trying to figure this laser out. So for example, you see that vineyard inspection form right there. So one of the companies have developed that vineyard inspection ArcGIS Survey 123 form for the farmers so that they can go in here and make sure all of their vines are doing great, right? And this map with the points that you see is our own map that we created, and the points are the soil sampling points. So while we collected soil samples, we also recorded them in the app, ArcGIS Survey 123 app, and then we have all these points. So when we actually get the data, we can, for each point, we can have data for each parameters, for example, pH or nitrogen or anything that you need. So it helps us to visualize how all these different parts in your farm or in your field are doing.
I'll just add, so record keeping is a huge part of being able to continue to grow, which is what Kavita just said. But also if you're a farmer that applies for grants or wants to be able to apply for grants, get some funding, or be able to speak to the work you've been doing, it's wonderful to be able to have a record to say, I've been tracking this for a couple seasons now, and I can show you on a graph that this thing will make for me so I don't have to make it, that this point, whether it's the thickness of the crops or the health of them or the impacts on the soil, is something that we can demonstrate because all of that data pertaining to that one thing is in one place that I can easily get. So I tend to be a hand note taker, but using this app has really helped with us being able to make sure that everything pertaining to something we need to be watching exists in one place that's easy to get to.
This is also really important from a university standpoint, an extension standpoint, to make sure that the research is really benefiting small farmers. By being able to track this data, if you're able to have recorded track data on a specific crop or area where you can say this intervention produced this result year over year, then that means that small farmers are able to apply for grants using that data to justify why they need access to this intervention, and it makes sure that those resources get to the people who actually need them.
So another thing that you can use GIS is for mapping the water source in your farm. For example, you have like a small pond there, you have a small stream that flows across the farm, right? And you can put all that information in the map, and then if you have your own irrigation channels, if you're like doing drip irrigation or any other form of irrigations, if you're pumping the water, groundwater, and getting it to somewhere else, and if there is a leakage or if there is a contamination somewhere, it helps you can put create an inventory of all of that information, and if there is a leakage or something or contamination or any problem, you can, based on so you can track where water is coming from, and that allows you to quickly pinpoint the location and also kind of put that information in the map so that it's easier for you, like when you go back and say, oh, hey, this is where the water leakage is coming from, so you can go in there and fix it. So that will ease you things up. So on this infographics here, I have listed some of this is not mine, this is somebody else's. So they have listed some of the applications of GIS in water resources. So GIS is used in water source management, flood risk mapping. So if certain part of your farm may be in risk of flood, you can map those out. And that also comes in handy when you actually have a flood and then you have to apply for insurance and stuff. So that would be easier that way. And then you can map groundwater, map water quality. Thank you. Okay. And then also allows you to select a dam site. Farmers don't need all of that, but I'm just laying it out for you what we can do. And then you can plan, design, and map the water supply networks, rainfall, runoff modeling. You can do that, irrigation planning, drought monitoring, stormwater management, modeling, river basin management. You can do all that stuff with GIS. So you can use GIS for that too.
We were just on a farm and did a water test of a stream and found that there was high phosphates. And this would be a great application for that farmer who can track where the water comes into their property, but then the water is obviously flowing through multiple other people's properties and ultimately comes from a core river. And so if we're able to use technology like this, even that individual person who's wondering how and where is this phosphate coming into my waterway, could help to identify that and maybe communicate with that neighbor or plan remediation strategies along their waterway to address this in critical places.
And other thing is we can use, this is especially where remote sensing comes in. We can use remote sensing in order to monitor carbon and ecosystem. And we can use it to track vegetation growth and track how much carbon is being stored in your farm. If you're an agroforester or if you're a like silviculturist, if you're, and that can be an excellent way to track how your trees are doing. And then also you can look at change detection, like how was the scenario maybe 5 years ago, how is it now, how are the plants growing, is the rate okay? And you can also monitor soil erosion and land cover change, and then also monitor ecosystem level impact in the reclamation, and that is some of the work that we have been doing in our reclaimed mine site. Richard, you want to add to that?
Family forest?
Yeah. So so with the carbon projects, this is another opportunity for small farmers to get access to like money and resources that they otherwise might not have. So there's a group called Family Forest Carbon is one of these examples where if you are a farmer that has a section of woods that is loggable, timberable, and they will pay you not to timber your property so that it will continue to sequester carbon. And this becomes an opportunity for small farmers who have unused forest land to get some money back and also be able to help sequester carbon and continue to help manage their property. So in order to do that, though, you need to be able to get the acreage of the area that you're working with. You need to be able to determine what the value of the log timberable asset within that is. For example, how many trees are over 12-inch diameter and of what species. And in order to determine that, if you have a very large property, that is going to take a very long time and be very difficult to estimate. That is something that you can use drone technology to be able to do so that small farmers who have that forest are able to get access to those resources. So it's just another really good practical use that gets resources in the hands of small farmers while also being able to help protect the environment.
And just to plug agroforestry here, there's, for folks who haven't heard this phrase, non-timber forest products. There are various things that actually grow that are of high value in our woodlands or could be cultivated in our woodlands. So combining a strategy that rewards you for keeping your canopy and then allows you to grow unique species under that canopy could be a nice kind of double up strategy for passive income.
For example, Lauren and I have done a bunch of mushroom inoculation, like inoculating logs with mushroom spores, which combines the same similar practices of looking for ways to help environmentally and property value-wise while also creating a commodity and food source. Because when you do your forest plan, in order to help maintain and have a healthy forest, they're going to tell you that you need to thin out certain trees to allow for other trees to be able to grow bigger, faster. And now you have all of these small trees that you just cut that are perfect for drilling holes into and inoculating with mushrooms that then will produce a passive food product for years to come. And we've actually taught classes on this as extension events in Martin County. So introducing other small farmers to these opportunities and teaching them how they're able to do that and presenting them to grant opportunities like the CAGP
Catalyzing Agroforestry
grant program, which also provides more resources to farmers to put these things into practice.
Yes. So this picture here, on this one, you can see that, so you see the dates on there, right? It's September 17, October 17. This is a research, but I'm just trying to show you how it allows you to monitor carbon and monitor vegetation. So all the green areas, so healthy vegetation area, and the red areas, so less healthy vegetation area. And we see that the vegetation are not so healthy during December to February, right? Which is understandable, even in where there are not deciduous trees. But this is just an example. This may not be applicable to you, but this is how you can kind of keep track of how healthy your vegetation are in different dates. Okay, now we come to drone applications. We already did touch a little bit about drone applications.
And I know you have many more presentations that'll touch on this too, so maybe we can
Yeah. So drones are a part of the technology, and they have been used in agriculture for many purposes. For example, they are used for analyzing soil based on how the reflectance of the soil is, and they are used for planning also, and spraying. So there are some spray drones where you can spray fertilizers, pesticides and stuff, and that reduces your workload a lot. And then drones are used for crop monitoring, irrigation, and health assessment of the plants. And not only that, you can also use drones in order to, if there is a disaster, a hurricane, tornado that destroyed your crop, you can use drones in order to inspect your property, your crops. And also you can use it to monitor your vegetation health, to detect if there is erosion or if there are any invasive species in your farm.
I want to comment just on the post-disaster, like the property inspection and the disaster related, which will come up as well in the next slide. This is another great opportunity to get resources into the hands of small farmers, in the sense that after these disasters happen, there's going to be insurance claims, there's going to be FEMA claims. The faster you're able to get the information of what was impacted and how bad it was, the more likely you are to get compensated for those damages. And using drones is a really good way to do that. It also is a really, really good tool that could be used more immediately following a disaster. So during February in Martin County, and y'all as well had flooding here, like we, for instance, were trapped on our mountain for 4 days, unable to leave. And in a situation like that, as soon as we were able to leave, we're doing food drives and delivering supplies and stuff like that. But using drones, you would be able to target those resources much more effectively, being able to see like which hauler has still closed off and that has power lines down and phone lines down and might not be able to get supplies or communicate that they need help. And so this is a big problem that happens in rural communities or areas that have more dispersed properties, smaller population, fewer resources, but are very prone to the impacts of disaster. And this is a very good way that drones could be used to benefit these communities in a disaster situation.
And also an interesting fact, drones are being now used to deliver emergency supplies to where it's needed. So that's a very good use of drones as well.
All right, well, we've talked about most of these actually, which is great, because then we don't have to go through a list. But this is just kind of a list that covers a lot of those top-down practical applications we talked about. And I'm just going to see if there's any we haven't really talked about here. Invasive species management, we talked about that slightly, but just to elaborate a bit, obviously we are on a reclaimed mine site, like we were talking about, which means that we are mostly dealing with invasive species management. That's our kind of primary gig, whether that's with sheep or with mechanical mechanisms or whatever it might be, trying to outcompete those with native species. So being able to use the LiDAR data that Kabita was talking about to be able to consistently track the placement and density of those invasives is a critical part of managing a larger property. And then Richard, I don't know if you want to speak to the animal things. I think everything else we covered pretty well.
Yeah. Also, just one last thing on the invasive species management. Other than monitoring the specific applications you're doing to control for the invasive species, if anyone here has ever seen a property logged and when the canopy gets fully opened up and how quickly invasives will take advantage of that open canopy to move in, if you don't manage that quickly and notice that quickly, you're going to have a huge problem for a very long time, and it's going to be expensive.
And unfortunately, loggers often leave roads not very easy to access.
So if you're able to use drones to be able to notice, oh, bush honeysuckle has started to come up over here, or kudzu has started to come up over here, autumn olive has started to come up over here, because you don't have to walk the entire grounds of your property, you can respond to the invasive species before it entirely takes over the property. And lastly, on the livestock, you can use the drones similar to the way that you might use your dogs to find the cattle that have wandered off your farm or the sheep that have wandered off your farm, to be able to monitor and look at entire areas and notice where they are. Luckily, they're not going to, hopefully, they don't end up being able to wrangle them for you, because cowboys still need a job. But the use of these drones for that is an excellent tool. I've also seen videos of people using drones as border collies to herd sheep. So I don't know much about that, but it's definitely an interesting and developing space.
But is a drone a good man's best friend? That's the question.
It's not as good of a companion, I don't think.
Cheaper to feed.
So we talked about a lot today, and a lot of things might be new to you, and we talked about it, but we really didn't get time to talk about how you can do it. So a lot of the things we can help you with that. So what we can do is we have all of these students working with GIS. We have currently 22 students in our GIS class, and they all have their individual projects. So if you want to map out your farm, if you want to do a site suitability analysis for certain crops or something, you can reach out to us. I'll drop my contact information in there, and our students can help you with that. And not only that, and they can help you with mapping, data collection, and analysis. You can learn from them, and also you both can learn together. I'm sure there are a lot of things that they can learn from you as well. So case you can be a partner in your farm, drones and these technologies, initially, they can be a little expensive, especially if you're a small farmer and you don't have resources. So in that case, we can come to your farm, we can fly a drone in your farm and make a map for you to be able to use. So, and we also have all of these events coming up where you can participate and get more information. We have GIS Day on November 19 of this year, and we also have Ag Roundup coming up. I forgot the dates, but it is in September.
September 5th and 6th.
September 3 to 6.
5th and 6th.
5th
yeah.
and 6th,
5th and
okay.
6th.
September 5th and 6th, that's Ag Roundup. We are going to be showcasing some of the resources that we are doing, and we'll be in booths. You can ask for more information. And then, yeah, so please partner with us. We'll be happy to help you out, and that would be an excellent learning opportunity for the students as well. So if you want to do that, you can reach out to us. Before that, I would like to acknowledge some of the grants that made it possible to work on the things that we do. So, and we also want to thank our collaborator, Clifford Smith and team at Renew Appalachia. And then our funding came from Evan Allen's award, Studying Long-Term Agri-Ecosystem Changes in the Reclaimed Mineland Properties in Eastern Kentucky. Another award that recently expired, Strengthening Research and Teaching Capacity of KSU by Studying Interrelationships and Disruptions in Landscape Change and Ecosystem Functions in Kentucky's Appalachia. And then another grant, Enhancing Productivity, Diversification, and Sustainability by Infusing Geospatial Technology in Small and Medium-Sized Farms, and Geospatial Artificial Intelligence, Enhanced Curriculum for Minority Serving Institutions. And I would like to give my huge shout out to Dr. Buddhi Gewali, who is my supervisor and who is the main lead person for all the geospatial things happening at KSU. he made all of this possible, and he's always very supportive of the students and the farmers. So I would like to really acknowledge him for all the things that he has done for us and for KSU and for people of Kentucky. So here are our contact.
And I'm guessing we don't have time for questions, right, Savannah? Just all the time. We will take 2 questions. A couple is taken seriously. It's complicated, is the short answer. So in this case, we have a unique situation where there is an individual landowner who then is interested in restoration work and research and is collaborating with the university. I will say that is abnormal. A lot of the lands in Kentucky are still held by large landholding companies. For example, Kentucky River or Pocahontas Landholding Company. There are often affordable leases available, particularly for agriculture in those cases. You will occasionally find mine land properties for sale, and then in some cases they are still held by the mining companies themselves because the land is going to be held in bond until they've been able to satisfy a certain reclamation requirement to release it.
Okay. Yeah, so in a lot
It's
of
complicated.
Yeah, again, it's very complicated, and there needs to be more research done on this question. For instance, the area they locally referred to as the slate dump, which is right near where the trees are planted. That was a sludge pond, so that was where they would wash the coal using flocculant.
They wouldn't wash it there. They would wash it. They
Sorry,
would
and
wash
then
it down below.
they pumped the flocculant and washed mixture from washing the coal, which was done at the tipple site at the bottom by the railroad tracks. They would pump that up and then dump it in this giant pond, which often also included a lot of oil or chemicals and stuff like that, so that when they, during reclamation, cover that up and fill the pond with refuse that they blow off from the side of the mountain. It's a mixture that I don't know if you can really speak to without research of what is actually in that.
There seems to be from existing research that the standards for heavy metal contamination, for example, on a reclamation site are actually more stringent than a lot of large agricultural operations. I think one of the things that makes it complicated too is because of the way they recreate these contours, they're pushing kind of mixed soils that were once layered according to time and erosion and oxidation. They've blasted all that. They have a big mixed pile of it. So you might take a soil sample right here and walk 100 feet, and you're looking at a really different soil profile. So generally, it doesn't seem from what we know right now like there's widespread contamination, but there are specific areas that are important to identify. For example, where there's acid mine drainage or where washes occurred that could be highly contaminated. So part of what makes it difficult is that the sites are kind of like Frankenstein back together, and they're really inconsistent, which is another reason to use some of this technology, because it's not the common sense we were talking about earlier doesn't really apply. You're dealing with a really unique, strange ecosystem.
One comment I want to make on the mine land ownership question that also came up. This issue comes up a lot of times. So if you go look at, for instance, PVA maps or property maps that are given by the county for tax records, you will often notice that a lot of these mine lands have tons of owners listed and various owners listed. And a lot of this comes back to the history of the broad form deed. And if you're from Kentucky or here, you probably are familiar with this, but of pretty nefarious and unethical land ownership or taking tactics that occurred before mining and were taken advantage of by mining companies in order to be able to take those resources. So when it comes to questions of like mine land ownership and all of this, if you are interested in getting into doing farming or work on reclaimed mine lands, I would advise you to work with your local PVA and get a survey done and do that type of due diligence before you engage in activities, since questions of airships and questions of ownership and broad form deed are very common.
That's the good news. Thank you all so much for having us. We'll see you around.
I just want to say thank you to you all. Thank you to Lauren, Richard, and Kavita. I know that that was a lot of information, and I really, really appreciate you all coming out. I know for a fact 2 of them are from Martin County, so that's quite a bit of a drive. So I really, again, thank you so much for coming out. I know you may have been voluntold, but I appreciate it. So up next, we have Dr. Chilliwal Lalit and Jeremy Sandifer is going to be speaking. I will let them come and speak, and then after that, we will continue on with lunch. So if you all are ready, you can come up.
Hi, good morning, everyone. So, I'm Lalit Punmagar. I'm a research associate here at Kentucky State University. So, working on precision agriculture, like using the drones and technology to monitor the crops here. So, here today I'm going to talk about aerial phenotyping and its like applications uh, in the crop monitoring. Like we are currently working on soybeans. So I'm going to talk about that. We are also monitoring some cornfield of here at Benson Farm. So this is the background picture is our field. We have our soybean field here at Benson Farm. You can visit that as well. So these are the soybean this year for 2025 season. So like going forward with the aerial phenotyping and the use of drones and technology in agriculture, we can see like how the manual phenotyping are conducted in the field, like visiting the field in foot and the challenges associated with manual phenotyping, like going to the field times and again and looking after the growth and development of the crops and visualizing how the crops are doing in the field. Probably that are some of the critical challenges, like they have like they takes a lot of time, they requires a lot of labors, and with the time and labors there is a lot of cost associated with the manual phenotyping. Like whenever like not in the small land, but when the agriculture are conducted in large area, then lots of labor and the associated cost and time are required. In contrast, when we're going for the aerial phenotyping, like using the drones and different kinds of sensors fitted in the drones, the same tasks can be conducted in a short period of time. The crop monitoring tasks and the and like visualizing the crop health and the growth and development of the crops that can be done by the drones and the technology associated with the drones in a short period of time. So now we have to understand about the aerial phenotyping. Like phenotyping is like regular monitoring of the monitoring growth and development of the crops that can be done either manually or by using the different tools and technology we have. So aerial means that is done from the sky. Like there are different kinds of drones or the aerial platforms that are used. Like there are fixed winged drones or the or like there are other kinds of drone as well. So here we can see like drones, we can see the sensors, and we can see the advanced software or the technology that are associated with the aerial phenotyping. So this is the drones that we have that we are using currently. This is a DJI Matrix 300, and the other are the sensors. That one sensor is the LiDAR sensors that is used to study the vegetation growth, like vegetation crop height and crop canopy, crop biomass, and those kind of thing. And other one is the multispectral sensor that can give information about the crop health or crop stress or other crop information that our visible eyes cannot do. Like we can only see like the red, green, or the blue band information using our eyes, but these sensors gives information about the near infrared and also the red edge information, which are beyond the visible range, and that can provide critical information regarding the crop health. Ultimately, using the drones and sensors, farmers can make intervention in their farm with the informed decision. Like the farmers have to like make some different crop management process during the crop production process. Like they have to add inputs like fertilizer or the pesticide or those kind of inputs in their field, but they are doing in the blanket applications. Like they are like following the standard requirement or the standard recommended doses in the field, but our field are not always the same. Like the field properties are variable. Like some field are already they have enough nutrients in them. Some have the less nutrient than the threshold required. So because of this variability in the field conditions, the blanket application might cost farmers, because if some part of the land has already enough nutrient for the crop growth and development and giving the proper yield, then that part that does not need to be applied with the nutrient again. So that can be that those kind of monitoring of the field conditions can be done by the drones and using different kind of these sensors. So why crop monitoring is important? It's everybody knows that crop monitoring is very important to track how crop are doing, because in order to get the final yield, ultimately we care about the final yield, but to get the best yield or the optimum yield, it is necessary to track the growth and development of the crops. Like if we monitor our field regularly in the weekly basis or in the bi-weekly basis, we can detect the problems in the field or the problem in our crops earlier than they exceed the damage level. Like so, it is necessary to monitor the crops, and also it also save our cost. Like if we go for the preventive approaches earlier than the control, then we can save the associated cost in the input. Like if we plan for the earlier application of the herbicide in the field, rather than the weeds are highly grown, then the cost can be saved by a greater margin. Similarly, I already mentioned, it improves the final yield and the quality of the crops. Similarly, the time and the labor that are associated with the field operation can also be saved through the routine crop monitoring. So here in the figure we can see the crop with sufficient nitrogen, and on the right hand side we can see the crop with the deficient nitrogen. The regular field monitoring can help us to identify what parts of the crops are stressed with the pest or with the nutrient or water, and what parts of the field are healthy. And based on those information, we can make field interventions. So for aerial phenotyping and the crop monitoring, so the tools used are like the drones. This is the prerequisite, and we use the sensors like the RGB, that is normal camera that our cell phone camera has, the multispectral that has a multi-band. Beyond the RGB, it has other kinds of bands as well, like near infrared, red edge. Those are critical for providing the crop health information. So the thermal sensor provides the information about the temperature and the water stress to the crops and in the field. Similarly, the LiDAR can provide the information about the crop architecture, like I already mentioned, crop height, biomass, and canopy cover, those kind of things. So here we can see the drones. The drone on the right hand side is the spray drones that was used in our field this summer in order to spray the herbicides in the soybean field. So here are some applications of the drones and associated sensors and technology in the agriculture. Like it is helpful to track the growth of the crops. Like we can see how the plant growth is using the plant height measurement, or how canopy cover is in the field. Through the plant height and canopy cover, we can see at what stage and at what period of the growth our crops are doing. Like we can see in soybean, like the optimum or the average plant height should be around 75 centimeter based on the cultivars. But like if the plant height is not up to their mark, we can say that there is needed for some farm interventions, like whether there is the requirement of the irrigation or there is a requirement of the nutrients like the nitrogen or other critical nutrients, or is there any weed pressure in the field. So it helps us to like make decision, like whether we need to go for the nutrient application or irrigation, regular irrigation, or we need to go forward to control the weeds in order to get the optimum yield. Similarly, we can also detect different parts of the field, like what parts are in the proper condition or what parts are with the patches. Like there might be some soil condition that might have contributed to the patchy growth of the crops. So based on this, we can make the decision like what kind of like farm operation we need to do, whether irrigation, whether nutrient application, or controlling the weeds, insects, or pests in the field. Here in the figure, we can see the tracking of the crop growth using the drones from the emergence to the maturity of the corns. Like on different stages of the crop growth and development, they have different height and different canopy cover. Like the drone can help to navigate those information, provide the information, and based on those information, we can make the decision whether to go for what kind of field intervention we need. Similarly, we can also navigate the nutrient condition of the field based on the images we obtained from the drones and the sensors. Like the green part here means the healthy vegetations, whereas the red or the orange part, they means that the parts are those parts of the field are not good, or they are deprived of the proper soil moisture or the soil nutrient conditions. So, and that they are reflected by the crop condition on those parts. So like based on those kind of maps, field maps, we can make our decisions like what parts of the field are actually healthy, or what parts of the field has healthy crops, and what parts of field needs the management options, like whether to go for the irrigation or the nutrient application like urea, or we can or go for the weed controls. Those kind of information can be obtained by visualizing different maps. Here is the NDVI map that gives the crop health status using the using red band and near infrared band from the drone images. So based on this, like farmer can make the application decision based on what part is really needs the nutrient or the irrigation, and what parts has enough nutrients or enough irrigation or those kind of things. And this helps to save a lot of money of the farmers. Like they don't need to go for the blanket application of the nutrients. They can just apply the nutrient in those parts of the field that really needs the nutrients, and they can left other parts as it is because they have a good amount of nutrient. Similarly, like the drone images can also provide information about the water stress and the irrigation. As we can see here in the figure, like we can see the blue parts are the healthy vegetation or healthy vegetation that has the optimum irrigation or optimum water in them, whereas those ones with the red patches are like the unhealthy or they are devoid of the irrigations. So using those kind of image information, like the farmers can go and make the decision regarding which parts of the field needs irrigation and which parts of the field has enough soil moisture for the plant growth and development. So it helps the farmers to make the irrigation decision in their field in a smart way, so that they can save a lot of water, which ultimately saves their cost as well. Similarly, like the weed are also they are the critical problem in the field. Like using the drone images and the technology associated with the drone images, the weed can be like, they can be segmented, they can be classified with the crops. The crops and the weeds can be classified, and like we can make a map where we can segment crops and weed, and the herbicide can be applied to the only portion of the field where the weeds are grown, and we can left the part where the crops are, where there are only crops, and we can only apply the herbicide to the weeds only. In this way, we can save a lot of money associated with the herbicide, and we can also improve the biodiversity, because a lot of herbicide means lots of chemical in the field. So like we can save the health of the biodiversity, health of the soil, health of the crops, and we can also save a lot of money by only the site-specific herbicide management decisions. So like it also helps to give information about the application of the herbicide at the right time, at the right concentration, at the right places. Because currently the herbicide application it is a blanket application. Drone are flown over the crops, and herbicide are applied at the same doses throughout the field. But once we generate this kind of map, herbicide map, and we can put this map in the drone system, and the drone can follow the map, and they can follow the path, and they can only spray to the right location where there are lots of weeds, and in this way lots of money associated with the herbicide cost can be saved. Similarly, the yield, yield is the critical parts of the agriculture operations. So like based on the drone images, we can like create different zones in our field. Like we can visualize what parts of our field are they are like they are good or they are really able to provide optimum yield, and what parts of the field really need the other intervention, like that really needs the soil health improvement, or like the irrigation properly, or the or or application of the fertilizer, or those kind of things. So using the drone images and using those information, we can make different zones of our field where we can, and based on those zones we can make our decisions. Like we don't need to make changes to those stable regions, like those regions that can provide optimum yield throughout the years or in multiple years, and we can just make our farming operations to those areas that really need our care. Like in the figure here, we can see the blue regions are high yield producing regions with the stable yield throughout the multiple years. Similarly, here in the green means they are providing the medium yield, and they are providing the stable yield in multiple years, and the red one are the unstable. They are not neither they are giving the good yield, neither they are stable throughout the multiple years. So this map is generated like by overlaying the multiple years yield map in one of the commercial farm. So like here, this kind of maps really helps to make decisions in the farm, like as we are always striving for good yield production of the crops, and using those kind of maps in the field, farmers can make really informed decisions. Like based on this map, then whenever going for the farming operation on the other year, farmers can make a decision by looking at this map and say that, okay, I don't have to make much farming intervention on the blue regions. I have to make my effort to get good yield on the red region of the red parts of the farm, or the red zones of the field. So in this way, the farming efforts, farm labors, times, and the cost can be saved using the drones, sensors, and other technology associated with this technology. So ultimately, the benefits of like using the drone technology, sensors, and the aerial phenotyping to the farmers are like it saves fertilizer, pesticide, and the water for the farm operations. They can get the higher yield using this technology. They can save time and labor and the associated cost with with the farming operations, and the technology can be eco-friendly, and since it always motivates for less chemical use, like less herbicide use, less pesticide use. So ultimately, the technology also motivates for environmental protection, biodiversity conservation, and those kind of things. So there are lots of challenges associated with the drone technology use, because the initial cost is high, like getting the drones, purchasing the drones, and the sensor associated with the drones. It is costly to the farmers, and also the farmers, they need training for operating the drones and like processing those images that they are obtained from different kind of sensors, and making those the making the meaningful use of the images is might be difficult to the farmers. And like the drone operation is challenged by the weather, because we cannot operate the drones at any time because it's affected by the wind condition, the rainfall pattern, the snow, those kind of thing. Or similarly, like the disturbance of the birds over our field, they might also disturb the regular drone flight. Here are some solutions, like there are different cooperative extensions and the service providers. They can help the farmers for this kind of service. And like the government and the university can also support the farmers for adopting this kind of technology to get the optimum yield in their field. Okay, so thank you. So we'd like to acknowledge USDA for providing all the supports for our field, for drone and all kind of things. And thank you.
Yeah, thank you, Lalit. So we're going to continue this session. So as Lalit mentioned, right, so drone has a different application. Drone can be used for crop monitoring. Drone can be used for nutrient detection in the field. Drone can be used for water management, right? So in this session, I'm going to talk about, like, I'll provide you some examples how we have used drones for different purposes in our resource field. For example, we have used drone to identify nutrient limitation in the field. We have used drone to monitor crop growth, crop physiology. We have used drone to predict crop yield. So we're going to talk about that. So we have used drone like in different crops, for example, soybean, sorghum, industrial hemp, rice, and sugarcane. So I'm going to talk about that. So before that, I'm going to start with my introduction. So my name is Anuj Chilwal, and I am an assistant professor of agronomy here at Kentucky State University. So I am an agronomist, crop physiologist by training, but I do have some interest and experiences with remote sensing. So that's why I have been integrating remote sensing, especially drone-based aerial phenotyping in my agronomic and crop physiology research. So I was introduced with this drone-based aerial phenotyping technology when I was a PhD student at Kansas State University. So at that time, I was working with sorghum. So during that time, I integrated this drone-based technology in one of my research. And after my PhD, then I did my postdoc at University of Kentucky and University of Florida. So at that time, I was working with soybean, industrial hemp, rice, and sugarcane. So during that period also, I worked with aerial phenotyping. I used drone-based aerial phenotyping for different purposes, so which I'm going to talk in a while. And then I joined Kentucky State University back in 2022. And here also, like, we have been using drone in soybean. We have been using drone for different purposes. So I'm going to talk all those my previous experiences. So first of all, let me start with my experiences in sorghum. As I mentioned earlier, so when I was doing my PhD at Kansas State University, I was working with sorghum. I was conducting different studies. So the goal of my studies is to improve abiotic stress tolerance in sorghum, to improve its heat stress tolerance, to improve its cold stress tolerance, to improve its drought stress tolerance. So in one of that study, like we were conducted that study in the field condition, we were trying to identify some cold tolerant sorghum lines, some cold tolerant sorghum genotypes, and we conducted that studies in the field. So sorghum is generally planted in like May or June, right? So that is the normal planting date. But we also did early planting. We also used early planting, for example, early April and middle of April, to provide cold stress to the plants so that we can identify some cold tolerant sorghum line. So that was the objective of the study, to identify some cold tolerant sorghum lines. So we have different planting dates, first planting April 1st, second planting April 15, and normal plantings. As you can see in this figure, in some of the plots, there are like very high germination. That means those cultivars are tolerant, cold tolerant cultivar, right? And some of the plots you can see there are no plants. That means those cultivars, those sorghum genotypes are cold sensitive. We are trying to identify some cold tolerant sorghum cultivar. So in that experiment, so we collected some data in the field, like we did collected some data manual in the field. For example, emergence percentage, stand count, seedling vigor. For that we harvested plant 1 month after emergence, and we collected plant biomass, shoot weight, root weight, and different plant growth and physiological parameter, and also grain yield. And in that field, we also fly drone. We fly drone and we extracted some vegetation indices. For example, NDVI and NDRE. So we extracted NDVI and NDRE. So we fly drone and we extracted those NDVI and NDRE data in each plot. And our objective was to test association between manual phenotyping with aerial phenotyping. We wanted to see if we can replace any of those traits with aerial phenotyping. So we used a multispectral camera which collects blue, green, red edge, and near-infrared images, and use different software. And here is the result of that study. If you can look at this figure, we also tested the association between NDVI and different those plant parameters, right? So you can see there is a very positive and strong correlation between NDVI with emergence percentage, NDVI with leaf area, NDVI with shoot weight, and NDVI with root volume, which means that when leaf area is lower, NDVI is also lower. When leaf area is higher, then NDVI is also higher. That means we can fly drone, we can extract NDVI, and we can estimate those parameters, right? And so from that study, we showed that we can use drone and we can identify some cold tolerant sorghum lines in the field, right? So for example, fly drone and see the NDVI, whichever plot has higher NDVI, that is the cold tolerant plant. So we don't need to go to the field and record all those parameters. What is the emergence percentage, what is the plant height, what is the chlorophyll concentration. So that was one of our study. We showed that we can use drone to identify cold tolerant sorghum lines. And then I joined the University of Kentucky as a postdoc. At that time I was working with soybean. And I was conducting different studies on soybean. And in one of that studies, I used drone to see if we can use drone to monitor nitrogen status in soybean field. So we are trying to see if we can use drone and identify any nitrogen limitation in the soybean field. So that was the objective of that studies, and we conducted this study in 2 different locations at University of Kentucky and University of Arkansas. And we used different soybean cultivars, nodulating cultivars and non-nodulating cultivars. Nodulating soybean cultivars means normal soybean cultivars which has nodules, so that's why we don't need to apply nitrogen. It has ability to capture nitrogen, right? Non-nodulating means it does not have nodules, so you have to provide additional nitrogen similar to other crops, for example, corn. And we also use different treatments, for example, no nitrogen, and we applied a lot of nitrogen. We also use different bacterial inoculant application, cover crop. So the goal was those treatment is to generate the variation in the nitrogen status in the soybean field, because we got to have variation to study the correlation, right? So that was the purpose of that study. And for the manual phenotyping, we went to the field, we collected biomass at regular regular stages, and we analyzed its nitrogen concentration in the lab. And for the manual phenotyping for the drone, we use drone and we use RGB camera, normal RGB camera. We collected RGB images. And then from those drone images, we used some aerial processing software and we extracted these indices, dark green color index. So from each plot, we have like soot nitrogen concentration that we analyze in the lab, and we have that DGCI value that we extracted from the drone images, right? Then again, we tested the association, we tested the correlation between that DGCI with that soot nitrogen concentration to see if we can replace that soot nitrogen concentration with the DGCI value, right? So here is the result, as you can see in this graph. So you have in the soot nitrogen concentration in the y-axis, and we have DGCI, right? So this is the DGCI value that we got from aerial images, and this is the soot nitrogen concentration that we got from the lab, right? So as you can see, there is very high and positive association, which means that when this DGCI value is low, nitrogen concentration is low. When DGCI value is high, nitrogen concentration is high. So there is very strong and positive correlation. That means we can just fly drone, right, and see in which area there is low DGCI value, right? That means in that plots or that area has nitrogen limitation. So that means we can use drone and we can identify the area with nitrogen limitation in the soybean field. So that is also like another example how we are able to use drone and we are able to identify the nitrogen status in the soybean field, right? So that was another like example that we used drone successfully to monitor nitrogen status. And then I moved to University of Florida. And at that time I was working with industrial hemp. So industrial hemp, like there was a ban for industrial hemp production for years, right? And government just lifted the ban at that time, and there was a lot of interest in growing industrial hemp. So our main objective is to see if we can identify some improved, some ideal cultivars for Florida's environment. So we are conducting different experiments. And in one of that experiments, I use drone again. I use drone to see if we can use that drone to monitor the crop growth and different parameters, and if we can predict its yield. So that was like on-farm experiment in farmer's field, and I used two different CBD cultivars, and then we have like 3 different plant spacing, and manually we collected those different parameters in the field. We went to the fields and we recorded canopy cover, we recorded plant height, we recorded biomass yield. And similarly, we also used drone, and we used that MicaSense Ultim camera, which is multispectral plus thermal camera. So it collects those different red, green, blue, red edge, near infrared, and also thermal images. And then I extracted again, like using drone, different software, I extracted different vegetation indices. And here is the like relationship. As you can see, this is canopy cover, right, that we recorded in the field, and this is NDVI. Again, you can see there is very strong and positive correlation. So we collected canopy cover during 4 different time period, 2 time in August and 2 time in July. And in each time, there was very high association, very high correlation. That means we can use the NDVI data that we collected from our drone images, and we can predict canopy cover. So we don't need to go to the field to estimate canopy cover, right? You have any question?
Now, is this data from one location? I see that you were in Florida, you were in Arkansas, you're here in Kentucky. Where did this experiment take place?
Yeah, so this one, industrial hemp in Florida. The sorghum, I talked about it, right? Sorghum, Kansas. And then soybean, that was at University of Kentucky. So when I was at Kansas State University, I was working with sorghum. When I was at the University of Kentucky, I was working with soybean, and this one at Florida, University of Florida. Thank you. So again, right, and so another relationship, this is the relationship between the plant height with NDRE. As you can see in the figure, this is the plant height, right? This is the NDRE, so we collected plant height at 4 different time points, right? And every time there is like very high association. So when plant height is higher, NDRE is also higher. When plant height is lower, NDVI is also lower. That means we can use NDRE value that from the drone, right, to estimate plant height. So we don't have to go to the field, right? We can just extract NDVI and we can predict plant height. Similarly, like another, like we are also able to predict the yield of the industrial hemp using another indices plus VARI. So from that experiment, we identified some of the indices, some of the aerial imagery indices to estimate those parameters. For example, canopy cover, we can use these NDBI, LCI, GNDBI, VARI, SIP2 for plant height. These are the indices we can use. For biomass yield, these are the indices you can use. So we were able to use drone and we were able to monitor different plant growth and physiological parameters such as canopy cover, plant height and biomass yield. So that is also another example how we successfully use this drone-based aerial phenotyping to monitor plant growth, plant physiology and yield prediction. Just example, I'm just showing some example, my personal, the example. And then, at that time, I was also working with rice. Again, in Florida, when I was in Florida, I was working with rice. As you can see in these pictures, rice is generally grown in the flooded condition, right? Rice is generally grown in the flooded condition. So what happens there, that whenever there is, in the area where there is water limitation, where there is like no water, that area gets hot. You see what I'm saying? So that means if we can identify those areas which has high temperature in the fields, that indicates that there is a water limitation. We need to irrigate that field, right? So that's why I used thermal camera, I used thermal images and I extracted the temperature of the field. Because high temperature means low water availability, right? And then I tested the association between the temperature of the field with NDVI. So as you can see in this figure, this is the temperature and this is the NDVI, right? So when there is a high temperature in the field, the NDVI is low. High temperature, low NDVI. Low NDVI means less biomass or unhealthy biomass, right? And when temperature is low, as you can see the temperature is around 26, the NDVI is high. So that means we can use aerial phenotyping to identify the area where there is water limitation, or we can say in that area where there is the temperature of the area where it is very hot, right? So from that experiment, we showed that we can use aerial phenotyping to identify that area in the rice field which has some water problem. So we got to irrigate that water, right? Irrigate the area. So that is also another application. We can successfully use aerial phenotyping to monitor the water status in rice and also other field. And similarly, there also like at Florida, I also did another side project. At that time, I was working with sugarcane. So in Florida, they grow a lot of sugarcane, and Florida sugarcane growers, they use controlled burning to facilitate sugarcane harvesting and processing, to make sugarcane harvesting and processing easier. So they burn the field and they put out the fire and they harvest the sugarcane. So you see what I'm saying? So first they put the fire and to remove all those dried leaf to make sugarcane harvesting and processing easier. And then they put out the fire and they harvest the sugarcane plot. And in this experiment, we are trying to see what would be its impact on soil health. Because you are burning the fire, right? So what would be this impact, the high temp, like burning impact on soil health? So I used that thermal cameras and I collected these images a day after the harvest, the day after the burning. So as you can see in this figure, even after the day after the burning, some of the areas are still very hot. So if you look at this figure, So some of the areas were cold, like 25 degrees Celsius, and some of the areas like you can see 80 degrees Celsius in the field. Similarly, if you look at this on the field, some of the areas has 71 degrees Celsius. So even after the day after they burn, some of the areas were still hot. So we were trying to see its impact on soil, different soil physical, soil properties. But during the same time, then I got this position, so I moved to Kentucky State University, and so I was not able to finish wrap up that projects. But we were able to use drone to monitor soil temperature in sugarcane field, right? As you can see. So these are some of my previous experiences before coming to Kentucky State University. And then I joined Kentucky State University in 2022, and I also wanted to do some aerial phenotyping work here at Kentucky State University. And I was working with soybean. I was conducting different studies to see if we can improve soybean seed protein concentration, because declining soybean seed protein concentration has become one of the major concerns. So there also we are integrating some drone-based aerial phenotyping in our research plots over there. And my graduate students, now research associate, he was taking care of that project. So I'm gonna hand it over to him to talk about our studies, aerial phenotyping studies in soybean here at KSU farm. So after Lalit is done with discussing that results, then we're gonna take your questions, all of the questions, okay? So Lalit, yeah, without further ado, you can go ahead and talk about the findings that he got in the research plot here at KSU. Yeah.
Thank you, Dr. Chilwell. So here at KSU, we have multiple projects related to the soybean and the use of drones and those technology in the soybean field. So first study we conducted was to study the application of the drones and other sensors for plant height estimation in soybean. The plant height is one of the critical phenotyping traits that is associated with the crop biomass and the crop yield in the soybean. So we were trying to find if drones and the sensors can be used to estimate the plant height in the field or not, because the plant height measurement using the human labors is very tedious task, because it needs lots of time and it requires lots of labors if conducted in the huge area of land. So here in the figure we can see on the left hand side we can see our fellow lab members working in the field measuring the plant height of the soybean. And on the right hand side we can see the use of drones and the sensors for the plant height measurements in the soybean field here at KSU farm. So the objective of the study were to identify, we used two sensors, that is one regular RGB camera and one LiDAR sensors. So the objective were to identify which one of the sensor is most effective for plant height estimation in soybean. So the objective were also to identify the limitations that were associated with each sensor while estimating plant height in soybean. This is the study area that is the Benson farm here at Kentucky State University. This is just the geographic location of the study area. So here we have some the information of the study area, and the experimental design was a split plot design, and we have plot dimension here. We have each plot of 7.3 by 1.9 meter. So this was the workflow that I followed for plant height estimation. We used different sensors and the different drones, and we used different software for processing those images that were obtained from the different sensors and different drones. And we also used ArcGIS, and we ultimately estimated the plant height from the drones, and that were used to correlate with manually measured plant height using a ruler in the field. So here are our results. The above scatter plots indicates the results for RGB derived plant height. drones and the RGB camera derived plant height against the manually measured plant height. Like here in the top scatter plot, we can see the manually measured plant height on the y-axis and the RGB derived plant height in the x-axis. So we can see we measured the plant height at 3 different stages on July 7, July 18, and August 29 that represented critical growth stage of the soybean that were like pod development, seed filling, and the physiological maturity stages of the soybean. So here we can see, R square value of 0.5 in all the stages. Like we can see the moderate correlation. That means we can say that drone and RGB camera can be used for plant height estimation in the soybean. When compared with the LiDAR derived plant height, we saw like stronger correlation between manually measured plant height and the drone and LiDAR measured plant height at 2 stages, but we saw there was a drastic decrease in the correlation values when the plant reaches to physiological maturity. This indicates that LiDAR was more superior for plant height estimation in the soybean in comparison to the RGB camera. However, when estimating plant height at the physiological maturity, we should still go for the low-cost RGB camera. So our research find that low-cost RGB camera can still be used for plant height estimation in soybean. And if we want, if we have budget and if we want higher accuracy, we can go for the LiDAR sensors. But RGB can also be useful to estimate plant height using the drones. So another study we conducted was to study the plant morphological and physiological parameters and the yields using the drones and the vegetation indices that were derived from the drones and the sensors. So here in the figure, we can see the correlation between different vegetation indices and the value like the plant height and like SPAD. SPAD means the leaf chlorophyll content. The SPAD value gives the leaf chlorophyll content, like what percentage of the chlorophyll is there on the plant or on the leaf, and based on that we can see like whether plant is healthy or not. Like if plant has higher SPAD value, that means plant are healthy, there is higher canopy cover. And if the plant has lower SPAD value, we can say the plant are unhealthy or they are devoid of the nutrient in the field, like they are devoid of the nutrient like nitrogen or the urea in the field. So when we see the correlation between some vegetation indices that were derived using drones, we find out that one of the indices like red edge chlorophyll index has higher correlation value with the plant height, and the green normalized difference vegetation index, that is GNDVI, has also significantly higher correlation with the SPAD value. This indicates that like we can still monitor plant height and other like SPAD value which is related to the chlorophyll content of the leaf with the drone derived images and the drone derived vegetation indices. And in this way we can still like figure out the vegetation health and the vegetation crop traits like crop height, crop chlorophyll content using the drone images. Similarly, we also correlated the drone derived vegetation indices against the leaf area index and the final yield of the soybean. We found out that both traits like leaf area index and the soybean final yield can also be estimated using the vegetation indices that are derived from the drones and the different sensors. Here we can see the results across different stages like date 2, date 3, date 4, date 5, date 6. This different dates indicates the different stages of the soybeans that we fly our drones. And here we can see like the correlation values across different stages with these critical plant traits like plant yield and the leaf area index. So this also showed that the drones images and the vegetation indices derived from the drones that can be used to navigate these traits and navigate or the estimate these kind of traits like final yields and the leaf area index in the soybean. So moving forward, what could be the future prospects of the drones? What would be the drones and the sensors? And this technology helps to the farmers. Like the drones in the research is getting like popularity these days, and lots of universities, lots of colleges have incorporated drone-based courses, syllabus, and they have incorporated this technology in their studies so that these technologies can be disseminated to the end users, and those are the farmers. And so the technology transfer are being to the farmers here. Like I saw, we have also we visited like some couple of counties, and we saw farmers are being interested towards the spray drones for spraying their fields. And here in the final image, we can see like farmers using the drones-based technology in their farms and making the farming operation based on the informed decisions they obtain from the drone-based technology. So the key takeaway from what we are all talking about is that the drones are useful tools. Like they are useful tools, and they can be made more useful for crop monitoring, for tracking the crop growth and development. And like drones, as we talked, they help to make an informed decision, because the informed decision and decisions are different. Like they can provide farmers the informations before making the decisions, so that farmers can get huge benefits and ultimately they can boost the agriculture productivity, crop yield, and those kind of thing. And so ultimately it can help for the smart farming in the future. Okay, thank you. So if you have any questions, the questions are welcome.
Yeah, I know it's already lunchtime, so if you have some quick questions, so yeah. Yep.
Thank you. Yes, my question is, these are a lot of good stuffs. Information, access to technology, access to resources. But if you do a survey, for example, in this room, we have some farmers here, I'm sure. If you ask them how many of them have used these drones or have experts come out there try to help them use these drones, I would assume, just my assumption, maybe 1 out of 10 or 2 out of 10 will say they have access to that. Why is the adoption rate low in Kentucky in terms of use of drones, GIS mapping, and stuff like that?
Yeah, thank you for the question. Yeah, I think that's a very good question. So not only in Kentucky, but also like all over the nation, the adoption rate of the drone by the farmers are still low. So basically, like we're still, under the research, like we're mostly focusing on research. Universities are doing research. So right now, like it is, the very high tech, right? You have to get a lot of knowledge, how to operate drone, how to do aerial images, processing and analysis. But we are making some significant progresses. For example, we are developing new drones which are very easier to fly, and also we are making progresses on aerial imagery analysis software right now. Like softwares are getting more user friendly. So previously you used to spend like at least a couple of days to stitch one images, and then we have to use another software to extract all the data. Right now there are new software, for example Pix 4D. You can generate everything in like within a hour, couple of hour. You can get like the plot level data, plot level NDVI, plot level NDRE. So just fly drone, put everything in one software, it will give everything. So I think it takes time. We are making some progresses. So when we make this technology more user friendly, and like more cost, also low cost, because like previously drone used to cost a lot. All these aerial images software is the processing, they cost a lot. So we are making some progresses, and then when this technology would be like less costly and more user friendly, and definitely automatically the adoption rate would go higher. Yeah. Yeah.
For the farmers who do not have access to the technology, is the university compliant with helping to assist the farmers with that resource?
Yeah, so is like our first presenter mentioned, right? So we have our students, they are conducting different projects every year. They conduct different projects. So if some of you are interested, to map your farm, because you don't have drone, right? You don't have drone, you don't have software, then you can reach out to our university. And so the student, they are conducting individual project for their courses, so they can collaborate with you. They can come to your your farm, and they can map your field, so they can help you. Yeah. So just reach out to our university, and we can connect to some students, and they can help map out your field, and also show you how to fly drone, and also train you.
That was a comment, a question from my wife, Emlyn Brooks. Most of you know me, some of you may not. And I'm Tony Brooks is my wife, Emlyn Brooks, and we're Turner Brooks Farm in Richmond, Kentucky, in Madison County. And I'm an alumni of Kentucky State University. And we try to stay connected and come to the workshops, and we appreciate all of your presentations and all of you who work here. A lot of things have been going on with the USDA, with FSA, with NRCS, as far as Washington and certain policies and certain freezes on the money that is allocated to farmers. Also, it was mentioned today in the presentation about grants that are available. And being a retired educator, I know that sometimes when you're presenting to a group, we may not have been taking notes or writing down, well, what grant was that, and how do we access that grant, and whether or not after your presentation, interested parties would be able to sit down with you, if time permits, to be able to say, well, we're interested in that, and how do we partner with you to be able to make that happen? Because we were at another workshop, and there was someone from Kentucky State that says, yes, we will bring a drone out to your farm. And he did show up, and he brought his drone, but I think that's been several months ago, and we didn't connect after that. So I have no idea what he did. He came to the farm, he brought the drone, and that was the end of it. So as far as the research that it takes to keep Kentucky State being one of the great, I'm trying to, whatever the certification that Kentucky State has to have to continue as a great university, for them to be able to receive grants to make this program, viable, not only for the sustainability of the university, but also to reach out in the community to be able to help farmers. And also students. I walked outside and met the new students. We have new professors. There's a turnover. Some of the professors that we worked with in the past are no longer here. There are new ones who come in. There are new students. And I think that I'm not going to put the onus on you all, but as far as myself as a farmer, and especially a minority farmer, a farmer of color, and an alumni of Kentucky State University, I'm going to keep trying to push that partnership and to be able to not just sit here and listen, but to be active in making sure that we have viable partnerships.
Yeah, thank you for the suggestion. Yeah, I think, yeah, we are all here to help, farmers. So we value like your cooperation and those things. So yeah, just feel free to, visit my office, and also we have like different faculty. They are working on different areas, right? So yeah, we are here, actually we are here to help you. Yeah, yeah, definitely. Also, like I am not sure who took aerial images in his field. Any idea? Do you have any idea? Yeah, like do you know like who is the person name who took who fly drone in your? We can connect. I mean, we can double check with that person and see. Otherwise, as you mentioned, I think I'm gonna give you like one email address. So maybe you can connect. You can send email to that person, and then, I mean, we can connect with you some student, and they're gonna come to your farm, and they will take like they'll fly drone and map your field, and then they also gonna show you how to take those all those things. So yeah, I'll meet you after this, and then we talk more about that. But thank you, yeah, thank you for your suggestion. Yeah, yeah. Any other question? Is lunch is ready or what?
I have a few announcements. I just want to say thank you all for speaking again. I know you all have busy schedules, and I really appreciate it. So just a couple announcements for those who kind of joined us later than this morning. We are doing a fourth Wednesday in September, so that'll be September 24th. That's our beef cattle meeting. Dinner is provided. It starts at 6, and it is held here at the research farm. If anybody wants to join, please feel free. There is no registration required. And then also our Kentucky Small Farmers Conference will be held November 18th through the 20th. And most of the sessions will be here at the research farm. We will have a banquet at the Capitol Plaza Hotel, and we will also have a health fair the last morning on the 20th. If you would like more information for that, my email is on the back of the agenda, or you can come up to me and talk to me anytime. I am more than happy to help you out. So today for lunch, we are having sandwiches from 3Ps. We have turkey and cheddar, ham and baby Swiss, chicken salad, egg salad, and veggie patch. So they're all out in the hallway if you all want to get up and go ahead and get lunch, and then come back, and then we'll start 45 minutes to an hour. So, all right.
If you end up not being able to hear me, just say so and I'll move it around. She's gathering everybody up. We're going to get started here in 1 minute, I think. Got it. Hey, what's your name, bro? Who you work with? Okay.
Philip?
Okay.
Yeah.
Doing community research stuff?
Yeah, but I work on one horticulture.
Okay. Cool. Are we ready to go? Okay. Well, thank everybody for coming back. I hope your lunch was enjoyable. What kind of sandwich was that? A turkey? All right, that's what I got, the ham. All right, good. Well, thank y'all for being here. I hope you were here earlier this morning for the presentations from our soybean guys. They're real live scientists out doing some exciting work, the soil stuff, and the drones have been, real useful for what they're doing. What I'm going to talk about is a little bit about my job as state specialist in ag tech for small farms. So half the time, really, my job is to be a resource to you guys, whether it's learning to get familiar with the technology, learning the rules, to study up, to get your drone license if you want to fly on a commercial basis and get paid for doing that. And this past August, or July into August, we just did 2 intensive weeks of training younger folks to actually learn to utilize the data, so to take on the GIS mapping and the remote sensing components. And I'm going to be showing you a bunch of pictures of that today, but we're not really going to get too much in the weeds unless somebody's super interested to know how we arrived at that data set. But mostly I just have pictures. And the point of showing many different kinds of pictures is hopefully one of my examples will be the example that's at your place. And when you see these pictures, I'm trying to explain how we're using them, but hopefully that'll speak to you and you say, oh, I want that for my farm for this reason. And then that's a great place for us to start our conversation and go from there. So let's see what we got. I do have a lot of slides, but I'm going to fly through them like really, really quick because, like I said, they're all pictures. Very briefly, I'm just going to discuss what the technology actually is, and then pretty much all of my pictures are just examples of stuff I've been doing recently. Some of it's connected to these other scientists' research. Most of them are grant projects, but my job is pretty much outreach and we don't have to get too carried away with running an experiment and documenting that all up. Sometimes we're just making a map, and that's all we do. So we'll look at that. Technically, this work that I'm going to be talking about, it all falls under geospatial technology. Maybe it sounds like a funny word, but it's around you all the time. And this image here is kind of showing 2 wings of this. So on the left-hand side, you have GIS, a Geographic Information System. There's already so much data out there. For the last 20 years, the US government has collected every shred of data on a repeat cycle that you couldn't imagine. NAPE, for example, monitors the entire country every single year. They know every acre that's plowed, every acre that's planted, every acre that's harvested. Now they do this primarily for the crop insurance reasons, but there's lots of other uses for this data since it's already being collected. So GIS is all about using pre-existing data, of which there's a lot. Now on the right-hand side, this is like another science known as remote sensing. So this is how you can fly over the land and basically check its health without actually touching the ground. So mostly we're doing this through cameras. So every time you take a shot with your iPhone, you're basically doing that. But we have a lot of different types of sensors that can give you different types of information, and that's what a lot of my examples are going to show you. Just to zoom way out, way before the drones, this science, this art of monitoring the Earth without touching it, they've been doing this since at least the 60s, maybe a little bit before that. So there's all kinds of satellites that have been up there for decades collecting information about how the Earth is going. And here on the screen is the entire story regarding climate change. We're not going to talk about the politics of it at all. We're not even going to talk about what drives it or what one would expect to be able to do about it. But when they talk about what's happening in the North Pole, where deforestation may be happening in the central parts of the globe, they're not guessing, they're not making that up. We're watching it like a movie. So these satellites have been observing the Earth for like 60 years. This is how we know for certainty all the things that have taken place on the Earth for 60 years. So just to run through this real quick, on the bottom left here, you have, this is a model showing the release of carbon dioxide through the globe and then how it gets mixed into the atmosphere. And then here on the bottom right, this is the greening up and the greening down on an annual basis of all the vegetation in the Earth. Now these are important because obviously CO2 provides food for the forests and stuff, but if over time you start removing forests, you have less ability to absorb the carbon that's in the atmosphere, so it builds over time. On the top here, this is air surface temperature at 6 feet. In the middle, you have polar ice, and on the right, you have sea surface temperatures. So these are all changes in Earth's environment that are driven directly by the increase in CO2. Okay? There's no mystery there. There's no question there. That is what's been happening as documented and monitored by satellites. But the scale of this is very large, right? To the individual farmer, this information doesn't seem relevant to your farm. And that's where are you trying to get a picture of that? And I'd be happy to send you this if you wanted. So that's kind of current state of the art. So if you're studying the whole globe, or if you're interested in what's been happening over multiple decades, this is the scale data that's available to you. But nowadays we use the drone. So the problem here is the problem with the satellites is every time you look in the sky, it's always cloudy. It's always cloudy. Even on days that it's very nice, the sky is full of clouds. So most of the time when the satellite looks down at the Earth, what does it see? It sees clouds. Most of the data that's available for you to get is full of clouds because it's always cloudy. Well, the drone doesn't have that problem. A, it's way below the clouds even on a cloudy day, and B, you get the shot when you want it. For those other products, it may have a 3-week revisit time before it comes back to your farm. And it's going to be cloudy, so it's going to have to make that trip 7 times before we get one shot. We're 2 years in already, and we only got one piece of data. The drones don't suffer from this problem. That's why it's revolutionary. And the scale now that we're looking is the individual blade, a leaf blade, if that's what you want to see, or the individual leaf on the plant, where before, that was at kilometer type resolution. And then right after I get done talking, we're going to go outside and fly a couple of these drones around. And this is pretty much the workhorse. If you were going to buy one, this is what I'd be pushing you toward. It's very standard, except it can see near infrared and red edge light. And I'll explain why that's important in a minute. But your eye cannot see this light. Your eye cannot see this light. but we have to be able to measure it to be able to take a proper measurement of what portion of all the sunlight the plant is absorbing. So on the left, that's just showing you the spectrum of light as it comes from the sun, okay? And there's only that tiny portion in the middle that you can see. And up on the top right image, that's exactly the image your iPhone would take, okay? But my drone, because I can see near-infrared and red edge light, it still takes similar pictures like on this bottom right that you're used to, except I have to feed the energy I want to see into one of the available colors. So it looks a little funny, but in this case, where you see the bright blue in the bottom image, that shows you where near-infrared's being reflected very readily, and only healthy vegetation does that. And you've seen this out in the wild, this idea of different materials interacting with light in different ways. They use this technology for a long time now to fly over deserts and shine near-infrared light on the ground, and based on how it reflects off the surface, they can identify what they're looking at. The same way they can shine near-infrared light into outer space, and it bounces off of these planets, and that's how they can tell you what the atmosphere is composed of, based on how it reflects near-infrared light. So there's a lot of uses for the technology that are kind of space age, but it's all simplified in the drone basically to let us very easily be able to take pictures of plant health. And I won't go through that too much, but so how do we convert basically this picture to a picture of plant health? Plant health and light, what's the relationship? The light is what the plant eats, right? Consumes it. So out of all the light available from the sun, the plant really only wants the red and the blue light. The green light, let's say it's not as nutritious, so it doesn't eat it, so that's what's available. So when you look out on a healthy field full of grass, what color is it? It's going to be green, right? Because the red and the blue light's being used for photosynthesis. Now, what happens when a piece of the field starts to get sick? What's the very first thing a sick plant is probably going to do? But why first, though? It does get yellow, but why? What is it doing? Same thing you do when you don't feel well. Stop eating, right? Very first thing, I don't feel good, I don't want to eat. Plant does exactly the same thing. It stops consuming the red and blue light. And instantly, what happens to the color starts to yellow. If you take green finger paint and you pour red and blue back into it, and you start mixing it up, it turns yellow into brown, right? It's exactly what grass does when it dies. Why? Because the plant is no longer needing to eat, so it doesn't do this light absorption thing. So at that point, we know it's not viable. So in a field that was planted in April, and I look out there right now, it should be homogeneously green. Anybody who's not green has a problem. Drone doesn't know what it is. Drone pilot doesn't know what it is, but we identify there's a problem here, and you either were expecting it, or we can bring you to say, what's going on right here? Now you've identified it. Once you locate these things on the map, you can basically upload it into your model, and the next time you see it, you'll recognize it. So you got to train it first. So we could show you all the problem areas in the field simply because they look different than everybody else. So that part of it's pretty easy. Then you would have to identify it. We incorporate that into the model, which is also known as machine learning, and eventually the drone's flying through recognizing what we taught it to see. That's kind of how that works in an idealistic way. Okay, so basically how much red light compared to how much near-infrared light, I can make a fraction out of that, and I basically have a quantified number on a scale of -1 to +1, how healthy the plant is. Plant consumes more light, we call it more healthy. Plant consumes less light, less healthy, okay? So what the absolute level should be, I couldn't tell you. But when I look at a field, they should all be the same, and whoever's different, they're out of cycle. That's the problem, okay? So this is satellite imagery. It's a European system satellite. If the clouds weren't a problem, the revisit time on this thing is 2 days anywhere on the globe. So what you see here, this is actually somewhere in the middle of Europe, but it's available for the whole world. And this is from space, okay, capturing the whole globe. This is in 10-foot resolution. You could monitor every single field in the county, every field, every acre. You can see the progress of it, but you can even see the variation within the field, okay? Now they're big 10-meter pixels, but these are almost your management zones already right there. But this data is not always available to be able to make this product. So this is no substitute for the drone, but just with the frequent revisit time, you put together this series that shows the evolution of your fields. So that's from space. So now we want to do this with the drones. I go out, I come to your place. Everything's AI, so the drone's basically flying itself. All I do is just give it an indication of where that I care about. So I draw a square around the field. This is a rotational plot that's directly back behind here. And what the drone does is flies back and forth, taking picture that overlaps. Software stitches all that together and basically recreates the 3D nature of the environment. So we have exactly the topography of the ground, and we have everything standing on the surface modeled. So you have trees that have structure. We can show this in this type of data. Generally the same type of example here. This is just an animation. So those are all the pictures that were took. It took 2 flights to do it, so you can tell there's 2 clear different flights being put together. And then that's the 3D world. That's the 3D world being shown, okay? Now, this really shouldn't be possible because this basically should be Google Earth, okay? But because every point in the image, you see it in a lot of different photos. So using Trig, you're able to put it exactly where it goes in 3D space. And when you do that for 1 billion points and you put them all together, you have exactly the 3D world out there. Look at that, that's really cool. You got the topography, you can see everything sitting on top. I could segment your trees, I can tell you how tall everything is. That's actually, he's not here, that's David Neville's property that, right there that we're looking at. So now if I zoom in to the particular plots, okay, and how are the scientists using this? Well, the scientists here at this farm, every field's got something else going on. They're either trying out something different with the soil, or they're growing 2 plots that have different varieties of corn, say. So in this example I'm about to show, there's corn, 2 different types of hemp, some pasture, soy, and sunflower. So, so this takes to fly the drone 2 times, and each time I'm making a measurement of its photosynthesis, my NDVI value here, so that's what's being represented. The more green it is, the more vigorous growth it's doing. So the question here was just about how well everything filled in. Notice you can even count your individuals. Okay, so if there was a question about what portion of the seeds I planted survived into plants, you get a measure of that. And then 1 month later, you get a measure of how well it filled in, covered the ground, which individual plants died or not. And then you can also extract out the height. So here we have a measure of how vigorous and how healthy it got in the first month of growth. And then here we're able to measure precisely how high it grew. So if you're doing browsing, like where it's important to, measure how tall the grass is going, you could get a density measure of that and then use these volumes to estimate exactly how much biomass is available for like goat farming or whatever. Does anybody do rotational browsing? Rotational browsing. Does anybody not know what that is? You're trying to put a bunch of goats out here or cows on a grass, but you don't want to just give them their own way out there. You want to control their movements in the area. You want them to eat everything that's there, but you don't want them to then continue eating it until they've destroyed it and it can't grow back. So Dr. Andres here was trying to figure out for this little section back here where all the goats still are, he divided that whole area into many, many paddocks and tried a bunch of different combinations. So many goats in each paddock for so many days. I can't tell you all the numbers he did. I can't even remember a single one, but some of them say would have 5 goats for 2 days, and another plot would have 10 goats for 4 days or something. And he wanted to eat all of what's there, but not eat it down so much that it couldn't survive and grow back very full when he moved them to a new section. So we wanted to say, can we use the drones to measure each time he does the switch? So this image on the left, every time he moved the animals, not every time, but most every time, we would take an image like this. Now that's good, but it shows you the plant health today. So obviously, and here's the scale. So if you're dark green, you're super healthy and robust. If you're up in the purples, you're almost dead. Okay, and then this is the grass that's out here back behind the place. So obviously where it's purple, he just had goats there, okay? And then where it's nice and green, maybe they didn't have goats or didn't have goats very long, okay? But just one day doesn't tell you anything, okay? One day tells you nothing. You got to collect this imagery for years. In this case, the whole project period was about 4 years, but we weren't on it all the time, okay? But for the imagery we did collect, this image here shows you what the trend over time was. So in this image on the right, where you have the dark green, the vigorousness, the photosynthetic vigorousness of the grass increased by 10%. I think this translates directly as in there's 10% more biomass available there at a baseline. The red and the orange, you have losses over time. So even on the whatever day here, they didn't look that bad. Over time, where there's the pink and the red, this means the goats were left on there too long, they ate it down too much, and the grass did not recover the growing season. So those are the areas that he left them on there way too long. All these nice dark green patches, like here, the plots look terrible. It looks like the goats ate up everything. But it ain't about the one day, it's about what I did over 4 seasons. Over 4 seasons, at that same strategy, increase 10% more biomass. So this is a real example where the drones were able to monitor his management strategy and quantify its impact to the land. Now, it took a long time, and maybe we didn't even catch the imagery on all the best dates. But he was so happy with the results here because exactly the results on that map on the right-hand side is exactly what he was trying to make. It's exactly what he was trying to do. He knew the answer to some degree, but it was still an experiment. And so this is any given day. That's what it looks like today, but there's only so much information here. This one on the right, that's time. That's trend over time, over those 4 years. Same field, slightly different problem. If you look back there right now, it's all green grass, okay? And this is something I didn't know before we did this project. This map, if you saw it in regular RGB, just like here, this is all green, healthy grass, right? Like in the background. If I turn these RGB values into something called HSV, just another way of looking at color, now what I have grouping of things that are exactly alike on the surface. In browsing, not all grasses are equally nutritious. Some grasses are very good for browsing. Some of the grasses will actually make the animals sick, okay? First question, what is the distribution of grasses in this field? When I do this HSV model, you can already see the communities clustering. Whatever's in this community of grass, exactly the same thing is in this community of grass. And it is wholly separate than whatever this is. How do I know what's here? UK had to come out here with whatever you call the grass scientists, and they would lay a little stick, a little 1 meter by 1 meter stick, and then literally blade by blade count all the grasses that fell in that area. The results I saw showed in a little meter square, or maybe it's a foot square, there would be like 11 different grasses or 20 different grasses in a little small. So where I thought we were looking at homogeneous species, we're actually looking at homogeneous communities, okay? So they travel together. So you can see the gaps, right? If I just visit each color, I can identify what's there. And this is how I teach my map, or I teach the drone to recognize it when it sees it again. Whatever's in the blues, I just go and check it out and see what's there. Now I know what's in all the blues. Whatever's in the green, purple kind of matrix there, I just go check it out. I see what it is. Whatever this is, it's in all the places that share that pattern. Down here, because to some degree they knew the distribution of grasses there, they've been studying that for years. Back here in this part, one of their strategies were to try to change the distribution, change the grasses that are there. So whatever's here in the background, this kind of darker blue matrix, these were those bags from Roundstone. So these are like native seed bags that are specifically designed for this climate, gathered and sold in a little bag from a company called Roundstone. They basically installed that bag here, just a little canvas bag here, and over time, these communities have popped up. So they brought this and introduced it. It began to grow and reproduce, and now you have patches of it have spread all over the field. And we've tracked that over time. That's incredible, right? So somebody should go out there and measure the nutritional content of this, and then they could work backwards to say how the nutritional content of the grasslands of the farm area have evolved, particularly in this area as a result of the rotational grazing strategies. So that was 4 years to put all that together. So this is interesting stuff for your farm, and we can't do this overnight, but does this type of information change at all how you think about your operation, or could it? And if the answer is yes, we'd like to help you do these kinds of things. I teach my students how to do them. I work with other staff who have to do this as part of their experimentation, and we also have a goal to try to teach as many farmers or people that are in farm business to also do this. So we don't know the best way for making all those things happen. Because it is a big learning curve. I can't lie to you about it. And then let me leave you with a word of caution as it works for the imagery about plant health and stuff. Because they've been doing this for years. Everything I'm talking about, I learned how to do it from somebody else. I didn't make up any of this stuff. I didn't invent any of this stuff. I'm a student of remote sensing, and this is what everybody did before me, okay? Including Cornell. And they've been doing this yield mapping thing forever. They can monitor. We have so many different products we can create to say, here's what explains the variation in your field. What you care about is how that variation leads to yield. So you make a yield map. Combine goes and pulls your corn or your soy or whatever. The machine is able to count as it goes the yield that it's guiding. So it creates a map to show you where the yield come from. So from space, looking at plant health in the way that I've described with that NDVI index, you make maps like this. Show you how, because a corn plant that isn't absorbing light is not going to produce corn kernels. It just ain't, okay? If you got a high-performing, high vigorous photosynthesis, the plant's rocking. You know it's going to produce corn. Guess what happened this year, though? All the models I saw all year, bumper crop ahead, best year ever. Here, there, man, this stuff is growing so good. And from space, that's what it looked like. Guess what happened, though? I can't even explain what happened. I've heard a lot of things, but a lot of the corn, and this was in Indiana and Illinois and Iowa, I'm sure, particular series of seeds didn't pollinate very well, because as the plant grew, this tassel wrap thing happened here. Okay, among many other problems, but one of the problems this year, tassel wrap. So that's a corn crop. Let me just back up. Remember, I'm on my yield map. When you make the yield map, you would want to prove it. You go pull corn from here, see that it's terrible. Pull corn from yellow, see that it's better but not great. Pull from corn in the green, that should be your top. So what if we pull only from all the greens around the field? This is what we get. We have a bumper representative here, full rows, full length. This guy come out of the exact color. He too should have been this. And from space, he looked it. Why? Because his NDVI levels were maxed out. He was eating all the light that fell on his leaves, okay? But that's only half the story. There's another whole half of the biology that you're not capturing from above. And this year, it was a problem that we really couldn't see. So all the products that I'm telling you this year were screaming, oh, best crop ever. But there's a lot you can't see. So this is the actual corn that came out of some of these perfect optimal growing conditions. So the moral there is caution's warranted. So some of the signs are good, but you can't see everything. Most of these scientists that are out here working, if they're dealing with soil stuff, like in my soybean field, the two guys that were here that had the first two presentations, I work with them a lot, but all of their work is in the soil. We're looking at soybean growing on top of the soil. We can't even see the soil. We're hoping to be able to see differences between their management strategy manifested through the plant. But there's a lot of assumptions that you have to make about what the plant's doing. And the point I'm trying to show here is that, the indications are that, these fields are going to overproduce. But we can't see all the information that's important. So somebody would have made a mistake here and said, you're going to have the highest yields ever, but then lose the bet. So we'll be hearing more about that as harvest plays out. All right, now I'm going to switch gears a little bit to a different drone product. So everything I showed you up until now basically happens from a camera, a regular camera. And a lot of these same products you can make if you just take pictures with your phone. LiDAR is a little bit different. LiDAR works like a rangefinder. So LiDAR sensor emits a packet of protons, and they go through the surface, and they will reflect off of everything that they encounter. And the same packet of light can be reflected multiple times. So as the diagram shows, you fire a laser out of the bottom of the plane, it reflects first on the top of the tree, and then it will reflect on everything it hits until it hits and ultimately is reflected by the ground. Our equipment can only record 5 of these returns. The newest, best, latest, greatest, most expensive type sensors can do 12 of these. And I hear that's about the limit that'll ever happen. All right, but it's not doing one of those, it's doing 250,000 of those every second. So if you fly your whole 300 acres, you may have 10 billion points that are these measurements, but they basically make up, you know, the terrain of your land. Like that. This is actually a tourist site in China. But the point is still the same. It's kind of like pictures, and except here, every point has been a discrete measurement. And it even has the color and everything too. So this, you know, it's useful in the same way as imagery in some time, but where you have the trees and stuff, you have all the structural information. So you can, where before, the picture can only take a picture of the top of the tree, but this laser will penetrate down through the canopy and be able to see the ground under the tree. So that's an example of one there on the right. That's just a tiny little forested area. And generally, working with the forestry folks, we would generate 2D metrics. So this would be like maps that show you, like in the top left is just the max height. So that's generally what people are referring to as a canopy map, just showing you the locations of your trees and how tall they are. But there's all kind of other statistics that you can do to basically like say what's down in the bottom of the cloud. But those are kind of boring. But we can take this cloud and we can summarize it in a lot of different ways. And this is really where I would be teaching a lot of the students to do this kind of stuff, so I won't bore you all with it. But the point is to take a busy cloud that just has every single detail, and the whole point of like doing analysis or making a map is to provide a much more simplified kind of output that is still indicative of what all that original information is, but really only contains the information you need. So like say you wanted to know how many trees you had, we wouldn't make all these products. We would get to this point cloud, we would segment the trees, and you'd be returned a map that really looks more like this instead of one that just has the whole everything in it. And of course, that would, what you actually wanted would just be a function of what it was you were trying to find out for us being out there. How many trees, how much bush honeysuckle, how many new sinkholes, questions like this. Just more information about voxel. So this is also a lighter cloud. So this is from the bird's view looking down. The point here is just to show there's an analysis where you can segment each tree. So you got, you know, millions of trees out there. We can fly over them. The software can see differences in like how the tree shape is. So you can basically catch that it's there, count it, and then you could, if you could label enough of them, make a model to try to predict what all the types of trees are. But that's pretty hard, but people do it. And there's a bigger forested area. The guy here, this was close to the Opal battery factory they just built off 65. This is right across the road from that. And the landowner here sold right-of-way access for a road to go through. And as part of their contract, they were going to reimburse him for every tree destroyed as part of this thing. So we ended up with the task to count how many trees and to give some idea of how many of which types of trees. But anyway, that's what a map looks like that. Not really hard to do, you have to collect the data. And there's lots of other uses too that have nothing to do with what I've shown you today. In fact, I give this very talk I'm giving right now once a month, somewhere in the state, and it's normally a room full of farmers or people that work with municipal maintenance or whatever. They're doing things with the drones that I never mentioned. Top 2 uses of everybody I ever talked to, every farm group I ever talked to, nobody's really doing any of these things that I showed you. What do you think they're doing with the drone more than anything? Just flying around, looking at the fence line, looking for that errant cow that keeps getting out. That's what they're doing, saving steps. So the number one reason you should get a drone on your farm is so you can fly around to look at it every day instead of having to ride your four-wheeler around or ride your side-by-side or whatever. So in industry, most of the uses also don't require this whole GIS analytical type stuff, because mostly somebody just needs to fly and see what's there. So here is post-disaster. You had a big storm, came through, knocked out a bunch of these solar panels. Somebody's got to fly over there, count how many of them are broken, so we can get a plan to get them replaced. These are jobs they're hiring for today. Electrical system, electrical infrastructure is monitored all the time. The gas companies and the electric companies are responsible for monitoring their right-of-way. Not only after a problem happens, but they have to watch and catch a problem developing. And then in electrical stuff, they spend a lot of time just flying up and down the right-of-ways, looking at the equipment, because as something starts to fail, its first signature is it starts to get hot. So they can just fly, and anything that's hotter than the stuff around it, there's a problem. Drone doesn't see what the problem is, pilot has no idea, but they identify where it's at, and then they can send the expert out there to have a look at it. These are jobs they're hiring for right now. Gas right-of-way, anywhere you have transmission lines, they have to monitor that right-of-way to make sure you don't have vegetation encroachment. Okay, that's another use, real popular use with this. And then after you have all your information about your field, okay, and we've did every test, we've done all the monitoring, what else could you do? We have yet another class of drones. These drones are for delivering agriculture chemical. So these guys are competing with the pull behind boom. It's still a lot of work, and this thing only flies 7 minutes before it's out of juice and out of chemical. It needs to be refilled, so the turnover is still pretty high. But say it's been raining for 2 weeks. You got to let it dry for like a week or two before the big tractor and the big boom can get out there. This guy can fly as soon as it quits raining. So the last couple of years, these guys have really been doing well, And I hear this year they really did well spraying fungicides. A lot of your big farmers always waiting on helicopters still. So helicopters are, I guess, the most efficient way to deliver a bunch of chemical, but they don't always show up. They kind of follow the season around the country, and if the weather didn't go your way, your whole area is not going to get visited by the helicopters. All the seed companies that sell the seeds and the fertilizers, they have a list of all the drone people in that area that can provide that service. Because the seed people want to sell the seeds, want to sell the chemical, somebody's got to apply it, so they're 100% on board with this stuff. In addition to chemicals, do I have a picture? You can take the liquid hopper away and put in a dry hopper. So here, this is like a pellet fertilizer, but there's also a lot of cover crop seed distribution happening here. So before say the corn's halfway done, I don't know at what point, but before it's all the way done, the drones fly through and spread cover crop, and it starts to grow, and the corn keeps growing, and then by the time the corn's ready and you harvest, you've cleared the way now for the cover crop to immediately start growing up. The last 2 years, I've heard more people talk about that than probably anything else. And it's always a drone connected to that. Could they not have done that before with tractors? I don't know. But it seems relatively new, and everybody's really excited about doing cover crops with this type of technology. We do have a couple of these, but there's a lot larger of a legal framework that you got to work in. That's actually my next couple slides. Real quick with the drone stuff. If you have your own drone and you're working at your place, you're considered a hobbyist. No legal framework for you at all. If you fly a drone and you go to her farm and she pays you in any way, even with, say, dinner, that's considered compensation. You would definitely want a license for operating this. Who's out enforcing it every day? who's out checking every drone flyer to make sure they're licensed every day? Nobody. But when something goes wrong, they will come out of everywhere, okay? Follow the rules if you're gonna do the drone stuff, okay? Get the license. It's not that hard. It's like studying for your driver's license test. Just you didn't grow up riding around in a plane, probably. So pretty much everybody needs that unless you're a hobbyist. Every drone, no matter what, if it's gonna be in the national airspace, it must be registered. This is how they're keeping track of it. Just like you can't drive a car on the interstate with no tags on it, same goes for the drones, okay? And the drones basically fly by app, okay? So there's a digital footprint of you with the drone, and you've created this bridge of paperwork to connect the drone to you. When the drone flies, it's broadcasting, here's who I am. Not you and your name, but the drone serial number. But through here, you're connected. So the idea, eventually, the airspace is gonna be full of devices, but between these two slides, this is how they're gonna manage it and police it, okay? Are there ways to kind of opt out and sneak around the system? For sure. Is everybody doing that? I don't know. Me and everybody here, as far as I know, we're 100% following 100% of the rules 100% of the time. And lastly, last two slides. So the stuff that I showed you, this is what I spend, this is what I do during the day. I work with scientists do it. I work with a lot of students and teaching them how to do it. And I do a lot of demonstrations and classes like this, try to introduce this to the farming set. We also do a lot of traditional education stuff. So we have grad students. We have a lot of different staffs that work at other government agencies that are trying to incorporate this technology of the drone or the mapping or the remote sensing into their own work. So this summer, with some folks from Dr. Gawali's team, including Kabita, I don't know if she's still here, we organized some classroom. Mostly you see the grad students here, but the folks in the back, they work at different water places and different government agencies. But we basically talk about this stuff and teach them. And that picture on the right is actually Kabita had a group of high school students, so spending their summer learning how to do this stuff before they even get to college. And we also work, we do a lot of other outreach. So here on the left, this is a group of immigrants from the Congo. So they do a lot of their own farming and stuff, and they're very entrepreneurial. So they're interested in learning about these skills, not so much to apply those at their own farms, because their own farms are very tiny, but to deliver that out as a service to the rest of the community. So like a service in the ag. And then in the bottom right there, we're literally at a elementary in West Louisville, getting the young people interested. So at all age groups, at all places, everybody's into the drone stuff. And we got something for everybody. But remember, it's just a picture. It's just a map. It's only meaningful if you're using it and providing more meaning to it, okay? This, I've learned this the hard way. So that's pretty much it. If anybody has any questions, any particular questions, or if anybody's interested in doing something like this at your farm, I'd be willing to work with you. They give me the freedom to, basically to meet you wherever I can. So if you guys are interested and want to get baseline data established and start to learn some of these things, get a map first, and then maybe in a couple of months you join a class and start, drawing boxes on it or whatever's important. Somehow you got to embed meaning in the map. The picture goes a long way, but the machine learning is you literally have to label the imagery and tell the software, here's why it's important to me. It's got to understand you at that level. So that's where the work comes in. Any questions? All right, well, thank y'all very much for being here. Thank you. And I think that's it, right?
Unless you want to do demonstration as a
As soon as I put the mic down, we're going to walk out front, and I'm going to fly one of these little things around. If anybody wants to steer, if you want to drive it, now will be your chance. Thank you all again, and I'll see you out there.
All right, thank you. And I just want to thank again everybody for coming. I know this was, not everybody's, the state fair is going on, so. But I really appreciate everybody coming out. And if anybody has any questions for me, I will be here for a little while, so you can come up and ask anything that you need. But yeah, like Jeremy said, if you all want to go and head outside, he is going to show you all, and you all are more than welcome to stick around for that.